Hey everyone, welcome. This is another edition of HashiTalks India. I'm sure we have a lot of repeat audience here, but for those that are not aware, HashiTalks are global, themed, and regional live stream events organized by the HashiCorp community team. Our goal is to support practitioners around the world and amplify voices within the community. Themed and global events are produced in English. Regional events are produced usually in local languages. All HashiTalks are aired live both on YouTube and LinkedIn. So I'm really excited to join you all there. My name is Hari Ram Sankaran, and I have been here at Hashi for about 3 years. I am a practitioner and a leader at HashiCorp, and I'm very focused on bringing value to our customers with the Hashi stack. And being a practitioner myself, I'm super excited to see the breadth of topics that we have here at HashiTalks today. And if you have any questions or comments, we'd love for you to interact with us in the chat. As you do, please keep in mind our code of contact in this virtual space. In general, be welcoming, inclusive, friendly, and patient. Be considerate, be respectful, and be professional. Just common sense. You can review our code of contact at hashicorp.com/community-guidelines. With that, let's get started. We have really good content today. I work across the Hashi stack, but my first exposure to HashiCorp and its products was Terraform. And I've been a practitioner of Terraform for a while. And so I'm super excited to see a lot of good topics around that. What excites me more is the integrations that Terraform has with other solutions out there and the overall solution that it enables for our customers. And also, we'll see some topics around Packer, which I learned a lot after joining HashiCorp, and it's one that's really helped me save a lot of time. And I'm super excited to see our speakers talk about all of that. With that, let me introduce our first speaker, Kamalika Majumdar. She is also a repeat speaker, and I had the pleasure of hosting her last year as well. And she is herself a practitioner. She helps customers in a variety of domains, including banking, financials, insurance, e-commerce, etc. And I'm really excited that she's here to talk about test-driven delivery of infrastructure as code. With that, Kamalika.
Hello, everyone. Welcome to HashiTalks India. And today's talk is going to be about test-driven delivery of infrastructure as code. And we will be understanding how to test infrastructure as code, especially Terraform code, using two of the tools, both for unit test and integration test, and how to structure it and how you can get the benefits of testing infrastructure as code. So let's get started. First up, why test-driven delivery, and why do I call it test-driven delivery and not test-driven development, or TDD, which is the common term used for application testing? First up, for infrastructure, we all know that until and unless it is being tested or used, we really don't know whether the infrastructure has been created properly or not. So first up, test-driven delivery, because it has to be delivered. Even if it is for development purposes or for testing purposes, it has to be delivered to the users so that it can be, you can see how it works. So first up is reducing burden on application development cycle. So if you do not do test before delivery, you will be imposing more burden on your application development cycle to also test your infrastructure. Let's say you are creating infrastructure for your development purposes, and you do not have test, or you do not do test, or you're dependent on manual verification through your console, etc. Then you will have to wait until your application is deployed on that infrastructure to see that every requirement that the application has from infrastructure is actually satisfied by the infrastructure scope. So that means your infrastructure development cycle increases, and it puts extra responsibility responsibility on the application development cycle, because then things can fail in application due to the infrastructure. So that is why it is better to do test before you are delivering the infrastructure, so that you reduce that infrastructure testing burden, because application already would have a lot of testing scenarios. You do not want to impose even infrastructure testing on the application development cycle. So that's why reducing burden on application development cycle. Second reason is maintain production sanity. It must work from dev to prod. The whole reason of the entire DevOps movement 10 years back, or more than 10 years back, was because we were facing issues in developing and releasing in production. We would see a lot of production issues. We would see common scenarios like things in development, but it fails in production. So maintaining production sanity is very important, and that is why you need to test more and test early, so, especially infrastructure, and reduce testing, or do no testing on production at all. You need to be absolutely sure that if you're doing any upgrades, any new addition to your infrastructure, it should work in production and it should not break production. So maintaining production sanity is important, and that is why you should test before delivery and do test driven delivery. Third is zero downtime updates. We know technologies and updates keep coming in every month and sometimes even weeks, especially if you're using cloud. You'd see that the cloud providers release, to keep up with the latest technologies, they also upgrade their technologies. Let's say Kubernetes releases almost every month. There is a new version every month. And in line with that, even the cloud provider will upgrade it. So you will need to do regular updates, and it's more and nowadays it has been become more frequent with the extend or with the extension of softwares and newer software coming in. So you cannot afford downtimes every month for your production or even your development. If your developer is stuck for days because of a version upgrade, it really hampers the entire release cycle. So that is why zero downtime updates is possible only when you test your infrastructure prior to putting it in the development, in the application development cycle. So for these zero downtime updates. And the last 3 points, it is really not possible to mock everything like in application development, where we do TDD, which is test driven development, where you can mock application features and write tests to fail the application. In infrastructure, it's slightly different. It is not possible to mock an entire AWS's VPC on your network. You would be able to mock it as per behavior, but not the exact configurations that AWS have. And you should not and must not run tests in production. And hence, I call it test driven delivery instead of test driven development, because it's not just developing or writing the code, it's actually testing before you are even running even you're executing the infrastructure as code. So delivery starts from day one of your infrastructure as code, and hence I call it test driven delivery. So what do you know? How do we do test driven delivery or test infrastructure as code? You need two things. First up is environments on demand. Environment on demand is a setup where you can spin up environment, uh, do changes, and then it can be decommissioned or recreated at any time within minutes. Basically, a dynamic set of environments which can be brought up, and it can be as close as possible to production, and it can be tested, and then it can be brought down. This kind of environment on demand enables you to have faster testing cycles and faster delivery cycle, because then you can do performance based auto scaling and continuous delivery, and in fact you can also test backward compatibility. So this is very important, that you can spin up and spin down environments on demand so that you can test them, and at the same time you can also have a balance on your financial expenses on cloud, so that if you do not have it, you will have to retain an environment for a longer period of time just to test it. But if you adopt the concept and if you write your infrastructure as code with respect to creating environments on demand, then you have the flexibility of creating an environment within minutes, doing all the tests, be it performance, it can even be security testing, and then satisfying it, exporting these configs to production, and then you just retire that environment. And so you can do testing on demand, and you don't have to spend a lot of money on the environments. The second important thing that you need for test driven delivery is modular infrastructure, or modular infrastructure as code. Uh, you should not just automate. Nowadays, writing infrastructure as code has become very easy with Terraform because it's a DSL. You do not you don't have to absolutely have programming experience. You can get started on day one, and it's pretty easy to get onboarded. So on one hand, Terraform makes it very easy to start infrastructure as coding, but you should also follow some of the best practices of how to write Terraform, or what gives modularity to your infrastructure. So don't just automate or write everything inside one piece of code repository and put everything inside it. Try to modularize and parameterize your Terraform code or your infrastructure as code, whichever tools you are using. Make sure you can separate or segregate the units which are reusable or which can be reused in different parts of your software or your projects or your organization. So segregate the code into reusable modules, and even Terraform follows that. If you have seen Terraform registries, it has a concept of modules for individual resources or services that the cloud providers or whichever provider we are using. So segregate the code. We'll have to segregate the code into reusable modules, and then we'll have to create deployable environment specific provisioner, which are also modules. So I call it the module and provisioner setup or modular infrastructure as code. So I create modules and which can be tested individually as units, or we call it unit test. And then we have provisioner modules, which can be which are the integration of all these modules into the actual environments where the software is going to be delivered. So let's get into some demo, and let's see how this works in real life with Terraform code. So today's demo is going to be with Terraform for infrastructure as code, inspect for unit test of Terraform modules, and TerraTest for integration test of the provisioners or the environment specific deployers. So when I talk about modular infrastructure as code, you can see here is my code structure. So I divide my code into Terraform modules, which are individual units, which can be reused to constitute different kind of environment setup. So I have modules separated in different repositories, and the good part of splitting it into modules, individual modules, is that I can test them independently without impacting the entire infrastructure as code or without impacting other environments. Because let's say I want to test network, then I can just spin up this network module, and I can test various configurations within the network. Let's say I want to add an extra gateway, I can test it. I want to add an extra subnet, then I can just add it to this module and I can run my test into it. And sometimes some environments may not need everything that you have, but some may need everything you have. Let's say it may not need your certificate. So ACM, today's demo, I'm showing the code with respect to AWS. So these are all AWS specific modules. So ACM is AWS certificate manager. So let's say some needs a certificate, some do not need certificate. So you do not necessarily have to include everything. If you have everything inside one code repository and do not split it, then unnecessarily you will have to also implement these resources, which is not required by an environment. And plus, multi-tenant deployment becomes difficult if you do not split it into modules, or if you do not create modular infrastructure as code. The next set of module I call them provisioners, and these are actually the environment on demands that we create using the modules which are here. So as you can see, you can have environments. Let's say you can have admin environments, which can have all your centralized admin components. Let's say your VPNs, your CI/CD, your logging, monitoring, your security and SIEM services, etc. So you can have like this, and then you can have your non-production, which can be your dev, QA, staging. And these are separate repositories which you can have. Plus, you can split your production, because it's better in terms of security as well, to keep your production and non-production in a separate environments or separate repositories, so you do not impact the production. And this way you can actually, so if you look at my non-production environment, for example, I have a base configuration first, which will create a Terraform backend, and then it will create a public zone, which is the DNS zone, which I'll be using for my environment, for my non-production environment. And then I create the network here. So you can see all of these. So the practice that I follow is that provisioners should only refer to modules, and modules should only refer to resources, and that way I can do changes in one place and it gets updated in multiple environments, and I can, promote it to multiple environments. Because otherwise I'll have to go to each environment and do a change. Let's say I want to add an extra subnet in my environment, then I'll have to go to each of them and update. But in this case, if I only change my PF network module, it will be updated in once I test, of course, it will be updated in all the environments. So here, this is how I structure environment on demand here. Now to deploy, let's say even in non-production, you might need multiple environments for testing multiple scenarios. For example, you might need a development testing environment, and you need a user acceptance testing or UAT environment, or you might even need a exact replica production, which is for performance testing. Because especially for SaaS or online-based services, you would see most often features are released in terms of onboarding more customers. So when you have such kind of feature, you need to test whether your environment is actually performance ready. So in those cases, you need a temporary performance testing environment. So then you can create, you can actually create it in the non-production repository and use Terraform Workspace. So when you use Terraform Workspace for your environment, you don't have to create like a dev repository, QA repository, performance test, which you may not need forever. So what you can instead do is you can have a non-prod repository and use Terraform Workspace within that, and you can switch between environments. So your states are actually separated out within the non-production setup. Now let's look at how it actually works. I'm using AWS, so my backend is S3. So I'll show you how the configuration works in terms of S3. So first up, what we are going to do is we are going to execute each of these modules step by step, and then we are going to test each one of them using inspect, and then we are going to do an end-to-end testing using TerraTest. So let's see, let's first look into the unit tests. So first up is base. So before we create the non-prod network, we need to create the backend and the zones for the non-prod network. And in this demo, I'm also going to show, apart from network, we are going to deploy an EKS cluster, and we are going to deploy an application. So we'll test the end-to-end flow of first we'll test unit by unit, like first the network, first the initial backend setup, and then the network setup, and then the EKS cluster deployment. And then we are going to do an end-to-end test where it will show that the application the EKS cluster is successfully created and it can be used for application deployment. So let's see. First so I'm inside my non-prod repository, and I'm going to go inside my base. So you need to do some initial setup for inspect. So I would recommend that you go to inspect's website and see what inspect is based on Ruby. So you need to install some gem files and set up inspect on your local machine, or if you are using CI on your CI agent or Docker containers, whichever you prefer, you can use it. I'm going to show this demo on my local machine, but I will also show you how I use it on my CI if time permits. So first up, once you have installed inspect, you will have to create, you will have to initialize inspect, and when you do test in inspect initialization, it will create a certain structure, and you can see the structure that you can see here is it has a verified directory, and then it has an inspect.yaml. So inside the verified directory you have something called as controls. This is where the inspect resources and tests are written. So inspect is also a DSL like Terraform. So when you are actually executing inspect, you will find the structure is a lot similar to how Terraform resources are. And the reason I use inspect is it generates a good report at the end. Plus, since it's a DSL, it's easier for onboarding. You don't need to have programming background, or be an expert in certain Ruby to write inspect code. So you can get started with inspect for your unit testing. So here I have written an inspect test file inside its control, where I'm going to test. So basically, in the base provisioner, I'm creating a Terraform backend using S3 bucket. So I'm going to check whether the bucket is created, and whether the bucket is, this bucket is a private bucket. It should not be public because it will have my Terraform state. So I'm testing whether it is, I'm testing that it should not be public and it should exist. And I'm taking the bucket name, all these values from a file called Terraform JSON. Now, Terraform JSON is being created from the Terraform output, which is run when I execute Terraform apply. So uh, here we go. First, we do Terraform apply, of course, to run the entire setup. So yeah, you can see no changes because I have already run Terraform apply to save some time. So it has executed Terraform apply. Now, once Terraform apply is done, I need to run a Terraform. I need to copy the Terraform output into a JSON file so that inspect can read. So I'm going to I'm going to run Terraform output and uh, export it into JSON format under files, terraform.json, which is within the inspect directory itself, which is files Terraform. And this is a standard structure of inspect. So when you are creating inspect init, it will actually create a files directory. So you can use the inspect function profile and then file. So it's actually inside the profile, it will create it. So you can just follow the same thing. So you do this, and now I'm going to run the test. The command is inspect exec test verify. And this is going to check the Terraform output, the .json file, and then validate all the configurations. Okay, so it has failed because it is not able to find my region. So what I'll have to do is I'll have to export my region. I'm using AP South 1, which is AWS region AP South 1. And now I'm going to run my inspect test. Yeah. So you see the test was successful and it has actually returned all the, so the S3 bucket name is this, and it is exist. It is expected to exist. So it is a green, and likewise. And then it has also checked for all my name servers, which are correct. And the private zone, and the zone is public because I'll be using it for my certificates for EKS cluster. So it has tested. So this way I'm able to test unit by unit. Likewise, I will go to my network, and then I've already executed my network. So all I'm going to do is actually copy my output into my file. So once you do Terraform apply, then you have to do Terraform output and copy it to JSON file, and then you run inspect. So inspect, this way you can test module by module, and in fact, you can go one step ahead, and the AWS modules that I have shown here, you can in fact add your test inside each of the modules. It's like an unit test. So whenever you are pushing code inside your network module, it will automatically run your test. You can set your pipeline to run automatically inside your test, and that way you can have the real modular testing. For today's demo, I'm showing it from the provisioner side because I've just structured it to make it faster. So here you see it has failed. So if it fails, it will fail. Here it says that it has to include tags called environment. So probably my tag is different. It is not including it, but it has tested some of the other subnets. So likewise, you can create your test cases and check whether it is actually satisfying your environment or not, because here this is how you can test your unit by unit. Now let's say we have tested it unit by unit. Now how do we test it? We are creating an EKS cluster. So for our EKS cluster, I'll be running my tests again. And let's see how when an EKS cluster is created, it is created with, I am also deploying an ingress. So it creates it deploys a dummy service, which is actually accessible through. So you can see my dummy service is shared EKS ingress. Now what I'm going to do is in my integration test, I'm going to check whether my EKS, whether the end-to-end stuff like network is created and then the EKS cluster is able to deploy or not. So if I run, so here I'm going to first run my inspect, and let's see. So how do we do integration test? Once you have run module by module test using inspect, you would also want to know the entire flow, whether it is working or not. And for that, we are going to use TerraTest. So this is how TerraTest works. TerraTest needs some bit of a programming background because it is based on Golang. So you need to understand Golang to write TerraTest, but you can fairly use it. So if you see the reason TerraTest can be used for integration test is that it also includes an init apply. So in inspect, we have to apply Terraform apply and Terraform output separately and then run the inspect command. You can, of course, integrate them within your CI scripts. But if you want to run it locally, run the entire end-to-end test, you can use TerraTest using init apply. And then you can create your conditions like, say, URL equal to public endpoint, then HTTP. You can go, and here I'm checking my ingress endpoint here. So yeah, so my setup is EKS is ready. I'm just going to go back to my root, which is my non-prod repository, and I'm only going to run, I'm going to go inside my test repository, and I'm going to run my go command so that it runs the end-to-end test. So here you see that it will, so the reason I chose to use TerraTest for integration test is that in integration test, you can test the entire flow in one command. So you can have all your, you can go directory by directory, run your module by module, and then it will test the endpoint integration, that your final service, which is your ingress or your application, which is deployed on your EKS cluster, is actually working. Once it works, then you can give your EKS cluster to your development team, and then they can use it for their application deployment. One difference between inspec and teratest is that inspec gives you a nice report like this. The reports in teratest is kind of within like the terraform log, so you might find it difficult sometimes when you're running it in ci, but it serves the purpose. So you can see the logs are actually within. So what I prefer is a combination of both, so that module by module I get a report, and then I can run the entire end-to-end test and get the final the result where the application is working or not. So you see the final result, okay, test is pass. So it will only give you this. It does not have a nice formatting like inspec has. So you can use a combination of both, but then again there is a one thing in inspec where you need to apply it separately, copy the output, and then run inspec. So yeah, there are some pros and cons in both, but you can combine both of them and create your test driven delivery pipeline in your ci, which can look something similar similar to your in your, if you're using gitlab or if you're using jenkins, you can have them within your stages. So herein, this is how your test can look like when you're doing test driven delivery with terraform, and you can use inspec or teratest, or there can be other tools which can be used. You can use javascript tools as well to test if you are comfortable with javascript programming. However, for users or practitioners who are not familiar with those scripting languages, I find these two scripting tools are easier for onboarding and serves the purpose. So this is how my pipelines look like. First up, I'll do linting. I did not have time to show that, but linting is Terraform using Terraform formatting, which tests any kind of syntax error in your Terraform. So you can add linting, and then it can run Terraform validate and Terraform plan. Then you can run the inspect test, which is the unit test for every module. And then you can run your Terra test, which is the entire setup in one flow, which is the end-to-end testing, to which ends with your like a dummy application or any service which you can curl or you can access using HTTP. So thank you so much. This here ends test driven delivery talk on infrastructure as code. I hope this talk is useful for you, and you can utilize it in your day-to-day Terraform coding, and it helps you in getting some of the issues. It helps you in expediting your development process and saves you time from going from into the console and verifying each and every components after you deploy. So I hope this works. You can connect me in, these are my social media links, and you can also take a look at 10factorinfra.com. I write a lot about infrastructure, Terraform, etc. there. So that's all for today. Thank you.
Oop, Hari, you are muted.
I am so sorry. Hey, thank you so much, Kamalika. Loved this presentation. It just keeps, your presentations just keep getting better. I loved the fact that you touched on best practices, recommendations, and as a practitioner, I was just hooked when you talked about formatting and all of that. Super strong presentation. I really appreciate you being here. Next up, we have Neil Shah. He has mentored more than 10 hackathons and open source programs, and also 2,000 peers to contribute to open source programs. Here at HashiCorp, we love our community, and so we're so excited to have Neil Shah walk us through unlocking DevOps magic. Who doesn't love some magic? This is about mastering Terraform cloud workflows. So let's get started.
Hello and welcome to HashiTalk India. Today, we will see unlocking the DevOps magic while mastering the Terraform cloud workflows. Hi, I am Neil Shah, a DevOps community guy. You can connect with me on Twitter. So yeah, let's start with Terraform first. And what are the main advantages of using Terraform. So yeah, reproducibility. Why we say reproducibility? Because we can have the same infrastructure on multiple environments and it is very easy to go that. Next is version control. We can connect Terraform Cloud with different VCS to track the different versions, and also on local Terraform also we can see the different versions of our environments or configuration which we have updated. Third is automation. Yeah, Terraform is an ISC, infrastructure as code. Through it we can set up, we can spin up the infrastructure very fast, very rapidly, and also we can destroy the infrastructure in a minute. And we can also configure all the various cloud providers through it, so it's a cool automation. Next, what are the key concepts of Terraform? The provider. When we say we need to connect with different cloud providers, multiple cloud providers, how we will configure? We will configure through their APIs or something. So, provider is a thing which will interact with the different cloud API and help to automate the infrastructure. Next is resources. So when we connect with different API, we need to write some resources, some code in HCL. So resources are the main thing. Resources behavior. So this is the main thing. This is a key point of Terraform where we define our infrastructure objects, which are components, and we can store and locally also on remote also. Next is state file. So this is a thing which regularly we don't change on our own. This changes as we do updates, we do changes in our resources. So Terraform state has all the reasons and applications of what we have changed, and actually we don't delete this file. All the Terraform users must know this. Next is transition to Terraform Cloud. While Terraform can be used locally, transitioning to Terraform Cloud offers collaboration and many management features. Great. So let's see the introduction to Terraform Cloud. So it provides a cloud-based service where we collaborate and manage infrastructure resources with different multiple cloud providers. Next is workspaces, the key point of Terraform Cloud. So workspaces, it gives a small environment where we can have our resources and we can isolate the infrastructure. We can have public workspaces, we can have private workspaces. Let's say example, we have an application and the same application with some different features is given to some two different clients, and two different clients are in different regions in like world. One is some other continent and other is other continent. So what we generally do is we store their data in in the region nearby to them to reduce the cost, to optimize the latency. Yeah, we regularly do that. So what we will do is to make two separate workspaces for them and to isolate their infrastructure. Although they are same, their region are different. Well, this is a small example, but yeah, this could be done through this. Other is in an application, we have different phases. We have development phase, we have deployment phase, we have staging phase. So it could be configured through this, through different workspaces, making it workspaces different and including this small amount of people which are there for this for that sort of work. Next is what are the benefits of workspace management? So yeah, we can use as VCS, version control. So yeah, we can have the version control of infrastructure code. We can have collaboration as I previously told. A small team of people collab and differently work on the infrastructure deployment directly over here. So it's like really helpful for the production team. Next is state management. Yeah. So even though we say VCS, this is also a good thing. State management. State management is also important because every time we need to have the state file, which is really important. .tf state in Terraform, and yeah, we can definitely track this. So what are the Terraform Cloud features? We can remotely store our files. We can remotely store the infrastructure files, resources files, all the files. Can even store the .environment file there. Next is variable management. So variables are a bit important from as per my perspective because through variable you can reuse the code, you can have more flexibility, you can also reuse the code across multiple workspaces. So if you make some variable globally, then you can also use that to across multiple workspaces. Next is policy enforcement. So and Terraform, there are security policies, there are Sentinel policies that can be implemented to have best practice for your security purpose, for your organization or for your application. Because obviously, as a part of a deployment team or as a DevOps person, we obviously have some sort of concern for security, as in the DevSecOps. So it will also help to maintain the security. So what I suggest is, what are the best practices for Terraform Cloud is maintain a VCS, maintain a version control, similar to Git or GitLab, something, which will help to track your infrastructure as code. Next is modularize infrastructure code. So make small parts of code which you can use everywhere. So it will help you to be faster. Next is use variables because it makes more flexible, more reusable, and also make an output file, output.tf, where you actually see your how the output will be there. So it helps to go before production. What are the Terraform Cloud workflows? So yeah, it's a hub where all the centralized state management could be there, all the files could be there, and you can maintain because it's similarly like a hub. Why I say hub? A hub has all the network connections, terms, securities, and also the files. Similarly, the centralized state management is a thing where we can have all the things at the same place. We can also see the changes at the same place. The best thing I love is queuing parallel execution. It helps us to provide queue and parallel execution of plans, optimizing infrastructure updates. So yeah, here the deployment time can be reduced by queuing because there are almost some priority in every perspective. Because there are priorities, this need to be first in production. Obviously, we can do that, but why do do that thing manually? It can also be automatically. Next is cost optimization. Oh, optimization is estimation. Obviously, estimation doesn't have an optimization, but yeah, we need to see every time like how much cost estimation could be there. So sometimes we may reduce, but yeah, this is a good factor for cloud workflow. Next is notification triggers. Obviously, we can set some triggers for some events, and also it will help us like when the infrastructure is down or sometime, and also help us in where our volume is occupied above or something. There are many triggers, so yeah, it also helps. Let's implement GitOps workflow with Terraform Cloud and GitOps Actions. So it's a simple GitOps workflow. So what is GitOps? So in a layman language, using Git as a medium and implementing the automation of CI/CD pipeline using the workflows. So it's a Git and a layman language. sorry, it's GitOps and naming language. Yeah. So development team will make changes and will make a pull request. The workflow will check whether this was proper. It will pass through some test cases. If it passes, then it will directly give to the deployment server and it will be live there. So it's a simple GitOps. So yeah, how to implement the GitOps with Terraform Cloud. And also we are using GitHub Actions here. So firstly, you need a Terraform Cloud account. Make a Terraform Cloud workspace. Second is configure GitHub Actions. How to do this? I will work with this and the next slide. Third thing is configure GitHub secrets. So why secrets? Because yeah, every time you won't be there to authenticate manually. To automate this, you need a connection between GitHub and Terraform Cloud. So it will make a connection there. So yeah, I say we'll discuss the step 2 over here. So here's write dot GitHubs dot slash workflows slash something.yaml. So it will work as a workflow. So yeah, this the workflow name is Terraform apply, and what it does is on push branch main. So if something is pushed on main branch, it will be triggered, and the jobs will be configured. Job will be run there. The jobs are first is Terraform run on Ubuntu latest. So what is Ubuntu latest? It's a runner provided by Terraform. Provided by GitHub. GitHub provides some of the runners like Ubuntu, Linux, Windows. So there are some predefined runners. And what will happen after that is, so step by step, all the jobs will run sequentially because it maintains the sequence. First thing is name are just for namesake. It will do is you uses, then there are two things we are using version 1 of Terraform, then Terraform logging. It will directly authenticate with the secrets. We don't require anything here, and then it will init and approve, then it will configure directly. Next is this is simple example how to visualize Terraform workflows. So it's a simple job sequentially given, but yeah, it is required and written form, so you can visualize more impactfully. Next is update the Terraform configuration. Update the main.tf in our as per our requirement, and boom, it will work now. You have implemented GitOps. You can see if you have made any changes, all the triggers will be there. Terraform Cloud workflow. You can also see all the changes on the Terraform Cloud workflows. Next is that's a general scenario where this is working. So like private module registry, that is some VCS. If some code is implemented, it will trigger to Terraform Cloud. Terraform Cloud we can access through two ways: API, UI. What it does is it will configure remote operations. What are the remote operations is? Like let's say some example with remote operations are cost optimization, cost concurring, remote state filing. This could be done with all the multi-cloud employers, multi-cloud providers, and this could be accessed by the remote users. So this is the way how Terraform Cloud workflow works, and you can implement them easily. So deploy faster, fail less, and innovate more. If you have some questions, you can definitely connect with me. Thank you. Have a nice day.
Awesome. Thank you, Neil Shah. As anyone who started with Terraform on your laptop, I can attest. Moving to Terraform Cloud is the best thing I ever did. And the best news is we have a free version. Most of the practitioner workflows are available. So if you haven't tried Terraform Cloud before, feel the magic yourself. Try it out, just like Neil said. So thank you again, Neil Shah. By the way, quick announcement: if you like learning about HashiCorp tools and products and want to get more involved, with communities like these, we invite you to join a HashiCorp user group, Hugs, near you. Neil is actually a Hug co-organizer himself in a newly created Gandhinagar Hug. Join this or any of the 18 Hugs all over India. That's right, we have about 18 already, and we would love to have more. So we encourage you to join one near you or start your own. Up next, we have Dr. Rahul Gaikwad and Tamil Selvan Prakasam. Dr. Rahul Gaikwad is a lead DevOps consultant at AWS. He assists customers in migrating and modernizing workflows on the AWS cloud. He also holds a PhD in AI ops. Huge respect for that. AI is everything these days, and having a PhD in that, that's amazing. And also welcome Tamil Selvan Prakasam. They're going to talk about how to deploy security automations for AWS WAF solution by using Terraform. Take it away, Rahul and Tamil Selvan.
Hello everyone, welcome to HashiTalk India. Today we are going to talk about one of important, interesting and critical topic, that is security. We will demonstrate how to deploy the security automations for AWS WAF using Terraform. And then we will also talk about how our solution can protect your web application from common web exploits and bots. Let's get started. My name is Dr. Rahul Gaikwad. I am a lead DevOps consultant at AWS. I'm a part of Proso team where we help our customers to migrate and modernize our customer business critical workload on AWS cloud. I'm a HashiCorp certified on Terraform and Consul along with 6 AWS certification and other industry certifications. I am also an open source contributor to Terraform AWS provider and AWS Cloud Control provider. Me and my team has published many AWS Terraform solutions on open source platforms such as AWS Campus. Today with me, I have my colleague Tamil Selvan. He will join us in this session later to talk about the architecture and the demonstration of this solution. With that, let's get started with today's agenda. First, I will talk about the problem statement and some customer challenges. Then I will briefly share our proposed solution and its benefits. As this solution leverage AWS Web Service, so I will give you an overview of Web Service. Then Tamil will join us to talk about architecture and demonstration of this solution. Uh, let's talk about the problem statement and some real customer challenges. Being a ProSo consultant, we work on a different customer engagements, and those engagements are from different domains. Sometimes it's banking, finance, healthcare, or automobile, and so on. And what we have observed is like often customers are uh, insist on high security standards to protect their web application, right? Because of the criticality of the system and customers' PII data. So we have also observed while migrating on the cloud, customers faces challenges in the protecting their web application because customers may not know all the security services and solutions which are available on the AWS cloud. We have seen so many customers try to enable and manage their security configurations through manual efforts like using CLI or maybe AWS console. And as you know, it's almost impossible to manage those security configurations if you have multi-region or multi-account setup. And it's also not recommended to keep track of all these security configurations, provisioning, managing through the manual efforts, right? It's not scalable. And we have also seen that they have put a lot of efforts to manage these configurations through console, CLI, some APIs, and whatnot. So some customers are already started using infrastructure as a code, such as Terraform or CloudFormation, to provision and manage their infrastructure on the AWS cloud. And yes, this solution is already available as a CloudFormation template. However, customers, those are already using Terraform as a IAC tool, they are also demanding the same solution should be available in the Terraform so that their engineer team can leverage the same solution using the same IAC tool. So they do not need to manage different IAC tools in their environment. So we have seen that there is a need of Terraform Cloud Formation template and custom resources to be transformed into the Terraform. And we have also observed there are some limitations when you refactor CloudFormation template into reusable Terraform AWS modules. So as we talked about multiple problem statements and customer challenges, let's switch the gear and talk more about the solution. So our solution allows you to easily deploy and define your customizable web security rules for your web application. And it also enables you to control which legitimate traffic you want to allow to your web application. As our solution is developed in Terraform, that solution will reduce your manual efforts and errors. And you can easily integrate this solution in your automation pipeline, which will improve your deployment speed. So during the development of this solution, we have done the heavy lifting for you and transformed all the CloudFormation custom resources into Terraform modules and the resources. And apart from this, you do not need to switch your IAC tools, and you can still provision and manage your Terraform resources using the Terraform. So let's deep dive. So let's talk about WAP. So what is WAP? WAP stands for Web Application Firewall, and it's a AWS managed service to protect your web application from common exploits and attacks. Here are some benefits you can expect from WAP. The first one is frictionless setup. Actually, you can deploy WAP without changing your existing architecture. And you do not need to configure SSL, TLS, or DNS. The second benefit we can expect is integrated bot control. You can easily turn on AWS managed bot rules to protect your application against the common attacks. The third one is managed and custom rules. Actually, this WAP provides a very easy and ready to use managed and custom rules, which you can leverage. And the last one is simply pull in third-party rules. What it means is you can simply add third-party rules to your AWS Web ACL rules. So with that, let me talk about one of our solutions which are already available on our AWS platforms. Let me share the screen and walk us through the different solutions. Okay, I just opened the first link, which is available on AWS Solution Library as one of AWS solution, security automation for AWS Web. You can see we have a link for implementation guide, and on the right, you can see all the details has provided. Okay, you can open the view implementation guide. You can download the guide as well as template source code, and you will have the nice documentation, step-by-step approach, how you can deploy this solution using the cloud formation template. So the second link is more into the AWS prescriptive guidance. You can see this is the solution which we have published as a part of a AWS prescriptive guidance. Deploy the security automation for AWS Web solution using the Terraform. Here we have provided the code repository as well as the summary of the solution. What are the benefits you can expect from the solution? What are the prerequisites before you deploy the solution? Then the architecture diagram, how the code directory is structured. Then you can see we have provided all the details, which tools we have used, what services we have used, what are some best practices, and then you can follow this step-by-step approach to deploy this solution if you are looking for the solution to be deployed through the Terraform as a ISC. Okay, we have also provided some troubleshooting steps which we have observed and encountered during deployment of this solution. And we also provided some references if you want to deep dive into this solution. Then the third link is actual Terraform code. Okay, you can see this code is available on the open source platform, that is AWS sample, and you can see we have provided all the relevant information, including architecture diagram, deployment steps, and inputs, and some existing issues. And we are working on enhancing this solution, and soon we are going to publish the new release of this solution. With that, I will let Tamil talk about the architecture diagram of the solution and the demonstration of the solution. Over to you, Tamil. Thank you so much.
Hi everyone. Thank you very much, Rahul, for the great presentation, which is explained about problem statement and as well as solutions. So now I will walk through about the architecture and demo for the security web automations using Terraform. So before I go into that, I'll introduce myself. So I'm working in AWS as a DevOps consultant. I do work predominantly on various DevOps tools, and I do have a 4 AWS certifications, and I certified in the HashiCorp Associate for Terraform and Vault. Now I will walk through about the architecture. So here we do have a different types of users. One is valid users and attackers. So when the valid user trying to reach out the applications, they will not be facing any issues because it's happening through the proper authentication and authorization. When the attackers in the sense it could be bots, or it could be other than any valid user, it could be scrappers, or it could be anything. So when they are trying to access through any machine or someone to through the application, they will be reaching out the one endpoint which we have configured as a honey endpoint. So that can be configured into the any web application. So when the attacker is reaching that specific endpoint, that endpoint captures their IP addresses and it sends the logs and with a proper request including the IP addresses into the lambda function. So the lambda function, it parses the request and it pull the IP addresses from the logs and it sends back into the WAF rules. So we do have a different WAF rules configured, which is SQL injection and then accesses HTTP flood. So based on the access which they have done, so that would go through the respective rules by the respective lambda functions. So we do have a configured different Nesys, S3 and CloudWatch. So these are all helping us to analyze the logs for parsing the each request. So yeah, when the second time attacker is trying to access the web application, they will be blocked by WAF itself. because the lambda already updated the respective IP addresses into the rules. So attacker could not able to reach the web application. They'll get blocked by WAF itself. So this is adding another layer of security for the web applications. So here we could see the code base for the solution, and as well as the commands which we are going to use for deployment. We will be seeing this about in the further demo. Now I will walk through the demo. This is the code base for the solution. So here you could see modules folder. Under modules folder, as we have seen in the architecture, the required resources has been created as a module and we have kept them under this folder. So we do have a main.tf file, which is the main file, which will be calling the each module with the required properties. And we have a variables and locals.tf file as well, which is actually parsing the user input according to the needs, and then it will apply the right values into the variable. So next we'll see the Terraform variables file, which is we have provided as an example TFS file. Here you could see the different WAF rules are selected as a true or false. So based on the user needs, they can select whichever rules they wanted to apply in the account, and they can select only that rule and that will be deployed. The remaining it won't. Now we will deploy the solutions using the Terraform. So this is our working folder. I will be running the first Terraform init command to initialize the working directory and all the modules. Once that is completed, we will run both Terraform plan and apply to deploy our code into the account. The Terraform init is completed. Now we'll run a Terraform plan. While running a Terraform plan and apply, we need to provide the specific variable files as well, which we have given as an example one. You can use it. So I run a Terraform plan. So now it shows the execution plan which is going to be deployed during the apply. The plan is running. Yeah, the plan is completed. Now we can apply the changes into the account. So this is the one. It's going to deploy the actual infrastructure into the account. Again, while running a Terraform apply, we can provide the variable file. And you can provide the auto approval command as well if you don't want to approve it again in between. And now apply is going on. Yeah, now Terraform apply is completed. We could see all the resources got deployed, and these are the output section has been created. Now we will move it to console and we will see the resources which have been created, and we will test one of the WAF rule as well. This is the account where I deployed the resources. Now we will go to the WAF console. We could see the new WAF web basic rules got deployed, and under this rule you could see the many rules have been defined. So those are including custom rules as well as the inbuilt default rules as well. So these can be selected by the user which needs to be deployed and which is not required for them. So here the each rule has adding into the IP sets as well, which is covered. Like for one of the bad bot rule, I will go and I will show you the IP sets. So this is a customized rule. So in this IP sets, whatever the IP addresses we are going to add, either it will be blocked or allowed, depends on the condition we provided in the rule sets. So each rules has the separate IP sets as well. So now we will go back to the WAF bad bot rule. So you could see this IP, if any IP address is present in any one of them, either IPv6 or IPv4, that will be blocked here. So before going to the rule, we will see about bad bot rule, what bad bot rule actually it is. So this is to make a safer side for the web applications. So in the web applications, if any user trying to access this application without the proper access, like any through bad bot or through any scrappers, if they are trying to access this bad bot, it's have a one API gateway URL which can be configured into the any web application. So whoever trying to access using a bad bot or any other way instead of the valid user, so they will be end up to reaching into that endpoint, which is we called as a honey endpoint. So it's a trap. So when the user is reaching to that specific trap, then their IP addresses will be stored, and then Lambda function will actually grab the IP addresses and they will put back into the this WAF rule, so that when the next time user access from the same IP addresses, they will get blocked by WAF itself. So we will go through those and we will see the demo for that. So to get the honey endpoint URL, we have created in the output section. So this is the bad.honey endpoint URL. I'm going to directly access this URL through my browser, and I will see the IP addresses whether it is getting added or not. So I'm pasting this. You could see it is telling thanks for the visit, and its respective IP address it is putting my IP addresses. So you could, now we will refresh this. You could see the new IP sets got my IP addresses got added. So that when the next time user is trying to access from the same one, they will be getting blocked by WAF. So it's a more secure for the applications. Yeah, I have completed the demo. Thanks everyone who joined this session. It was a great pleasure to get a chance to talk on this HashiCorp talks. And if you have any questions about this solution, you can reach out to our LinkedIn account, which has been showing in the slides. Thank you.
Nice. That was a really awesome demo. I loved the depth of the demo and perfectly orchestrated between the two speakers. Thank you, Rahul and Tamal Selvan. Absolutely appreciate putting all that time into setting up a detailed demo like that. That was definitely my favorite part. I've worked with AWS WAF in the past, and there's so many nuances to it. And tying something like Terraform to automate that is can become very crucial, and in doing things faster. And for those that were reinvent, tying off of AWS products here, HashiCorp is obviously a huge partner. AWS provider is actually one of our more well-known and biggest Terraform modules out there. So please try out all these different modules that is available to you. And by the way, all the speakers here that have spoken, Rahul, Dr. Rahul, and others, Neil and others are still in the chat. So if you have questions, please feel free to ask the speakers in the live session chat. With that, I am super excited to invite our next speaker, who is Aniket Kumar Sinha. He is a cloud consultant at Rapid Circle with an impressive track record of being 4 times Microsoft certified. I have personally taken certifications, and I can attest that takes a lot of hard work. So kudos to you. He thrives in the dynamic world of Azure. As a cloud consultant, his daily playground involves orchestrating the intricacies of Azure. We just looked at AWS and moving into Azure, and then there's other GCP focused displays here in the presentations as well. They're all kind of speaks to Terraform being sort of that multi-cloud provider. And I appreciate Aniket bringing in the Azure perspective here. And Aniket's passion for community also shines brightly through his involvement in his teams, groups like Microsoft Learn Student Ambassadors and Google Developer Student Clubs. So I am really excited to have you here, Aniket, and super excited to hear you speak about revolutionizing the cloud infrastructure deployment and unleashing the power of integration. I know there's a lot to unpack here. GitHub Actions is one of my favorite topics as well, so I'm really excited that you're here to talk about that today. So, with that, Aniket, I'll hand it off to you.
Thank you so much, Hari, for this warm welcome. And welcome everyone to the HashiTalks India. And today I am going to talk about one of the really good scenarios which I faced in my project. So this is not just a demo-based scenario; it is a real-time scenario which one can face in any kind of projects. Thus, I am sharing one of my experience. And today we would be seeing how we can revolutionize the cloud infrastructure deployment with some special power of integration. So, hey everyone, short introduction again. And I'm Aniket Kumar Sinha. I work as the cloud consultant at Rapid Circle. And as Harish said, I am certified in four of the Microsoft Azure certifications. And I love to be part of communities and contribute to communities. I write blogs, I speak at multiple sessions. And this was a bit about me. If you want to connect with me, you can check out my social handle. And moving ahead with our talk, so you can see that we have a separated pen here or a separated side section here. So one will be covered by GitHub Actions and another would be covered by Terraform Cloud. So you can see that there is a separation between the GitHub Actions and Terraform Cloud right now. So now just imagine a scenario that you are working for a project where you are using Terraform infrastructure and you are using Terraform Cloud to deploy that specific infrastructure to your any cloud service provider. So we are taking the example of Microsoft Azure. Okay. So you are writing the code, you are creating the infrastructure, you are using the Terraform Cloud to deploy it using the Terraform Cloud workspace. You are using the pipeline there to run the pipeline and deploy your infrastructure over Azure. Right. But you may also want some of the scriptings. You may be using Python, you may be using PowerShell, or you may want to use some special kind of test, for example, pester tests. So for that case, you cannot use Terraform Cloud. For that case, you need some other CI/CD tool. And for this reason, we are taking an example of GitHub Actions workflows. Okay. So you have created the infrastructure, you have created your scripts or test. Now, what you need to do, you are running two specific pipelines over the two different platforms. So you are juggling between the Terraform Cloud to check your Terraform infrastructure, and you're also juggling between the GitHub Actions to check your other scripts, right? So you need to keep a track of two pipelines over the two separate platforms. And also, if you are getting any errors, you are getting any bugs, you need to fix in all over the two platforms separately. And you can only understand now that yeah, it is a really tough job, it is a really hectic job. But as a DevOps engineer, we would like to simplify the things, we like to automate the things, we don't like to juggle much over the different platforms, and that is what we would be doing today. So we would be trying to create a handshake between the Terraform Cloud and the GitHub Actions. And how we would be doing that? We would be trying to achieve an integration nirvana between the GitHub Actions and Terraform Cloud. So we would be ultimately integrating Terraform Cloud inside the GitHub Action workflow so that it can ease our work, and we would not need to shuffle or juggle between the two separate platforms. So let's now see that how we can do this. So first and the foremost important path is the Terraform Cloud. So we are currently trying to open the Terraform Cloud section, or this is the Terraform Cloud portal, and we would be creating a workspace because to deploy anything over Azure or to deploy anything over any cloud service provider, we need to use the Terraform Cloud workspaces as a medium. So we are creating a Terraform Cloud Workspace. We would be choosing an API-driven workflow. Why we would be choosing an API-driven workflow? We would be seeing it ahead. So let's name it as TFC-GH-integration, and let's select some of the already present project, and let's take integration Nirvana as just the description. And then we are creating this. Oh, sorry for this. Okay, then tap on create. So you can see now the workspace has been created, and you can check this code because it would be really important for us. So we have created an API driven workflow or the workspace. Now why we have created this API driven workspace? Because to create a connection or to integrate Terraform Cloud over the GitHub action, we need to create some kind of connection, and we would be using the API to create such connection. Okay, so now we also need some API token, right? So let's create that API token. So we would be going to the user settings, and under this user settings you would be getting an option to tokens. Okay, so this is an option to token. Now you can create a token here. So let's say TFC underscore integration, and you can set your specific expiration date, and then we would be tapping on generate. So you can see now our token has been generated, and this is the specific token which we would be using. Okay, so one important thing to be noted here, that we can create API tokens on the TFC in 3 different levels. Okay, so one is a user level token. Okay, so a user can create a token as its own level. Okay, second is the team level token. So we can create teams in Terraform Cloud, so you can create a token for that specific team. And third is the organization level token. So you can see that this specific, like my name is currently the organization name. Okay, so you might be using some other organization and you would be having that organization, so you can create a token to that organization level. So you cannot create a token to the specific workspace level. Now this is an important point to be noted, because we would be using some other things because of this reasons. So we have created the API token now. So now we need to add this specific token as a secret in our GitHub action. So we would be like copying this. We would be going to the GitHub, and then we are creating a new repository for our code and for our GitHub action workflow. Okay, so we are creating a tfc-gh-repo. Okay, we can add a description as integration Nirvana, and then we are just creating the repository. Okay, now we need to add this specific token as a secret to this repository. So how we would be doing that? We would be going to the settings, then we are having the secrets and variables section here. Okay, so we are tapping this, we are having the option of actions. So we are tapping on this action, and then we have the option of new repository secret. So we need to tap on this. Okay, add our secret here or the token here and the name. So we are using the same name which we given here. So we are tapping on this and then creating the secret or the token here. So now this specific secret or the API token has been added as a secret in our GitHub repository. Okay, so now we can use this specific secret in any of the code or in any of the workflows, and we would be doing the same. Now the API token has been generated. It has been added as a secret. Now let's create the main.tf file, which is one of the important part of this specific infrastructure. So let's name this as main.tf. Okay, now we got this specific code here, right? So we would be using this specific code in our main.tf file or in our providers.tf file if needed. So what this specific code is doing? So you can see that this Terraform block is having the cloud block. Okay, so this cloud block is having the organization name and the workspaces name. So organization name name is same as the organization, and we are having the workspace name. So as we discussed earlier, that we can only create tokens or the API tokens at user level, team level, and organization level. So how you would be making the GitHub action workflow understand that you need to deploy this specific infrastructure code to this specific workspaces, right? So how would you telling the workflow that you need to use this specific workspace to run the pipeline? So this is the cloud structure which we will be needing there to mention it. So that's why we are mentioning the workspace name. You can see this TFC integration, TFCGH integration. So let's copy this code and add this in our main.tf file. So this is an important part. Okay. So for the demo purpose, I have already created a repository with all the code structures, and I'm using that. So we have created this main.tf file, and we have added this cloud block here. Now we also added some extra blocks under Terraform. We have added the providers block for the Azure RM, and we have added a resource block section. So since we are using the Azure, so we have added some code blocks related to the Azure RM, and we are trying to deploy a resource. Let's take the resource group as an example resource to be deployed. Okay. So now we have created all the code structures. Now, say as we are discussing about Azure, so we need to create some connection to Azure too, right? So how we would be doing that? So we are going to the variables, and under variables, we would be adding our uh, like the details related to the Azure under this variable section. So for that case, we are already having an already created Terraform Cloud workspace with all the details mentioned there. So I am using that to showcase. So we have created the specific TFC integrated with GH actions as a workspace. And you can see that we have added this specific workspace here also in the code of the main.tf. So we are going to the variables tab. And you can see in the workspace variable, I have added the required details. And what are these? Client ID, client secret, subscription ID, tenant ID. These are the SPN related details. So whosoever is using the Azure, he or she must be aware about this, that how we can create a connection. So we are using such things. And then the code is done. The creation, the connection between the Terraform cloud and the GitHub action is done. The Terraform cloud workspace connection is also done. So now let's create the workflow under GitHub actions. So we are like creating a .github folder and then workflow, then deploy.yaml. So we are using this specific code. So what this code is containing. So we are adding the name of the GitHub action workflow. Okay. And then we are having these specific jobs. Okay. So under jobs, we are having a Terraform job, and the Terraform job is containing these entities. And you can see this is the checkout stage. So you can understand this checkout stage would be using the GitHub action token, sorry, the GitHub action workflows to run this. But the next code is the Terraform codes. So this code would be running over the TFC environment. Okay. So we are setting up the Terraform here. Okay. By setup Terraform, we are then adding the secret or the API token under the setup Terraform stage. Okay. And then we are having these simple steps as Terraform init, Terraform validate, Terraform plan, and Terraform apply. So now you can see that this checkout stage would be using the GitHub runners, and the other Terraform related stage would be using the Terraform cloud related runners. Okay. So this is the code structure for the YAML file, and you know that we need to create .yaml file under this specific code structure or the folder structure to create a specific GitHub actions workflow. Okay. So now our code part is done. Let's now check this workflow over the actions. So we are going to actions, we are going to the created workflow, and we are having this workflow. We can run the workflow from here. So to add more depth to this. So we are doing some changes in our resource or the main.tf file. So I am using the GitHub code spaces or the github.dev to do some minimal changes under the resource which we are deploying, that is the resource group. So we are just doing a minimal name change under that resource group so that we can see what changes or how the pipeline is running to show the different changes of the Terraform cloud and the GitHub actions. So the Terraform, so the GitHub code spaces is opening up, and here it is. So let's just remove some letters from our resource group name. Okay, so we are saving it and we are committing it and push. Okay, so let's now move back to our normal GitHub, and you can see that the name has been changed. Now we are going to the actions, we are going to the workflows, and then we are running the specific workflow. So now you can see this new run. So you can see the setup job is done, checkout is done, setup Terraform is also done. Okay. And then init, validate, and plan is running. Let's go to this specific section also. Yeah, this one. And you can go to the runs. You can see that a similar run is running here. So you can see even the code, the logs are also same. So let me just move this here and then use this specific log section to show you that how this is running. So you can see that the apply has started, and here also the apply started. So what happens when you are running the Terraform cloud run under the GitHub Actions? So it runs the plan phase separately in one of the separate pipeline, and again it runs a separate run or the separate pipeline run for the apply stage also. So we are having the Terraform apply stage. You would be saying the similar things that are coming up here are running here. Okay, so whatever would be shown here, the same thing would be here. So we are not running two separate pipelines, or we are not running the two separate platforms. So the Terraform code or the Terraform infrastructure code is running over the Terraform cloud. It is using the Terraform cloud runners to run it, and it is just showing a copy of that specific run or the specific log is coming up here. So you can also see that to view this run in the browser, visit this specific URL. So let's open this URL. So this URL will lead to you this specific run only. So it is opening up, and you can see that same run ID. See the run ID is same. So you can even manage your Terraform cloud run via GitHub Actions only. And you can see the same thing. It is still destroying. It is also showing still destroying. The same thing is running because it is running over the one single platform, and a copy or a duplicate of it is coming up in the GitHub Actions. So now you can check your plan phase, you can check your apply phase here, and even the cost estimations under the GitHub Actions only. You don't need to jump from GitHub Actions to Terraform Cloud for anything. Every log, even if it is failing, it is passing, every log would be coming up here in the GitHub Actions. So you don't need to jump to any other place. So this is the integration nirvana that we tried to achieve, and we have fully achieved it. So we are using the Terraform cloud, and in one of the previous sessions, this has been stated about the states logs. So I also want to cover up that we can lock the state under the Terraform cloud, because it is one of the very good feature of the Terraform cloud which is provided. So you can like tap on the lock state, and it is now locked, so no one can alter your specific current state file. Okay, no one can alter it, no one can rewrite over your infrastructure. And to showcase an example of that, I have one of the previous pipelines that can be a proof to you. So we are having this, and under the Terraform apply, you can see this waiting for manually locked workspace. So I locked the workspace at some time and then I forgot to unlock it and then I restarted running it. Okay. So it was not moving ahead. It was waiting for the lock to be unlocked. So if we are not unlocking the state lock, so it would try to run for a few times and would fail because the state is ultimately locked. So these are some of the benefits of Terraform clouds, and these are some of the benefits of achieving the integration nirvana between Terraform cloud and the GitHub actions. So you have ultimately achieved the integration nirvana. And talking about the recap of the stages, what we did. So we created the Terraform cloud workspace with the API driven workflow. We then created the API token. We then added that specific API token in the GitHub repository as the secret. And then we added that specific Azure related details under the our workspaces as the variables. And then we created our main.tf code, which added the Terraform code structure, where we added the cloud block containing the organization, the Terraform cloud organization name, and the Terraform cloud workspace name. And then we created our workflow file containing the details of the workflow, like setup, terraform init, terraform validate, terraform apply. And if you have some other scripts, some automation scripts, you can add it to this. If you have some tester test or some other kind of test, you can add to it. So this checkout stages or the any other stages which cannot run over the Terraform cloud would run over the GitHub runners. And from the setup Terraform stage to the apply stage would be running over the Terraform cloud or with the Terraform cloud runners. So this is the beauty of the Terraform that is offered. So you have also took a look at the workflow run. We have succeeded using the Terraform cloud integrated GitHub action workflow, right? So we are just using the GitHub actions now, or to just checking the GitHub actions workflow now, and the Terraform cloud is also getting used. The security of the Terraform cloud, the beauty of the pipeline of the Terraform cloud for the Terraform infrastructure is all there, but we don't need to juggle between the two platforms. So this was it for the integration nirvana. And if you want to go through the codes, or if you want the code of this integration nirvana steps, you can scan this QR code or move over to this bit.ly/tfc integration gh action, and you would be getting all the code structures there. And this is the state file migration. So this is another important link, or the which I would like to share. So suppose you are using a general structure of Terraform now, and you are storing your state file in any of the storage accounts. So if we are using the Azure, so we are storing our current state file in our Azure storage account. But you need to switch over to the Terraform cloud for the more security. So how you would be shifting or switching your current state file from your Azure storage account to the Terraform cloud is containing this. Because if we are just creating a new workspace and trying to run it over the Azure infrastructure, it would be giving us error, because the state file is ultimately holding what are the resources which are already deployed of the Azure, right? So there are some specific steps which you would be needing to shifting your state file from the storage account to the Terraform cloud, so that it should not give you any error. So these are some of the important links. And yeah, thank you for this uh, great platform for me to share about my experience. And thank you everyone who joined this specific talk. And you have achieved a really good integration nirvana par. Now you can use this in your current project, and you can scan this QR code or search for Linktree Aniket Kumar Sena to connect with me all over the platforms. Thank you. And if you have any questions, you can post it in the chat. I would be more than happy to help you out.
That was a lot of fun, Aniket. Fantastic. I got to tell you, I never get bored hearing the word Nirvana. So I love every time you mentioned it. And great integration. And thank you so much for publishing the repository for all our listeners here today, that goes a long way in helping people and the community try these things out. So phenomenal job. Loved seeing the integration between GitHub Actions and Terraform. It really does simplify developers and others leveraging all of these to deploy infrastructure. So fantastic job. I know you've presented with HashiTalks before, so really thankful that you're here today. Quick reminders, we'll be sharing all of these talks on YouTube in the coming weeks. So if you're just tuning in, don't worry about anything. You can catch up later in YouTube as well. And also, if you're enjoying all the Hashi Talks and follow us on Twitter, hashtag HashiTalks. With that, thank you again, Anikith. And I would love to introduce again our next speaker who already presented today, who is Dr. Rahul Gaikwad. I mentioned he has a PhD in AI ops, and he's also hugely invested in community and has contributed a lot. So um, thank you again. Along with him, Ishwar Chautaiwale is also presenting today. And they're going to talk about Terraform Cloud with AWS Service Catalog, kind of remaining on the AWS integrations with Terraform Cloud. So I'm really excited for them to walk us through that presentation. So let's get started.
Again, hello everyone. Welcome to HashiTalks India. Thank you for joining our session that is integration of Terraform Cloud with AWS Service Catalog. In this session, I'm going to talk about one of the new feature of AWS Service Catalog, which was recently launched, that is on 10th of August this year, where it supports the integration with HashiCorp Terraform Cloud. We will demonstrate how you can integrate and deploy your Terraform solution using Terraform Cloud and AWS Service Catalog. With this integration, you can enable your end users to discover, provision, and operate your Terraform-based solution and cloud infrastructure. So with that, let's get started. My name is Dr. Rahul Gaikwad. I am based out of Pune, India. I am working as a lead DevOps consultant at AWS and having 13 plus years of IT experience. I'm a part of Proso team where we help our customers to migrate and modernize their AWS workload. And based on my open source contribution towards Terraform, I was recognized as an open source community contributor and AWS champion. And outside the work, I like to travel, meet with new people, and try out new dishes. Today with me, I have my colleague Ishwar. He will join us later to talk about architecture, solution, and demonstration. Let's go through the agenda. We will follow the same standard agenda. First, I will talk about the problem statement and some customer challenges and use cases. Then I will briefly share our proposed solution and its benefit. Then this integration talks about Terraform Cloud and AWS Service Catalog. So we will just talk about overview, what the services are and how it works. And then Ishwar will join us to talk about the architecture and demo. Let's get started. So before I talk about general problem statements, I just wanted to share one of a real customer use case which I encountered last year, where we were working on one of a reusable and public AWS plus Terraform solution. So we were discussing about how we can publish this solution so that our end users can leverage that solution in their environment. So we considered the traditional customer requirements, right, where they want to have a common product feature such as upgrades, rollbacks, versioning, multi-region, and multi-account deployments, etc. So we could not find any straightforward and easy way to fulfill all these requirements. From that real customer use cases, we figured out some of the challenges which may have encountered for multiple users. For example, challenges of Terraform versioning and deployments. Then there are some limitations in the Terraform, right? We cannot easily upgrade and roll back. Then we also observed that there is a need of simplified mechanism for multi-account deployments. And there is a lack of self-service provisioning model to remove your heavy lifting to manage the Terraform deployment infrastructure. So let's switch the gear and talk about the solution. So this solution helps you to manage Terraform versioning and deployments by using Service Catalog and the Terraform Cloud. It will enable you to upgrade and roll back your Terraform solution in your environments. Also, it will provide a simplified mechanism for your multi-region, multi-account deployments. The last one is the Terraform Cloud and Service Catalog integration will help you to provision a model which removes heavy lifting to manage your Terraform deployment infrastructure. Okay, with that, let's talk about the Terraform Cloud. So Terraform Cloud is a SaaS offering which provides a bunch of features, such as you can run your Terraform on the cloud. You don't need to run all your Terraform in your local machine. So Terraform Cloud backups your version file of your state file, and you can go back in time, and if something wrong, you can easily restore from your backups. Terraform also enables you the collaboration and governance features across the team. I will talk more about collaboration and governance. So let's try to understand how it works. You can see from the left, Terraform Cloud has a private registry where you can share your organization's Terraform modules and providers. Terraform Cloud provides a collaboration and governance features where you can run the Terraform plans and approvals at centralized place. Okay, and Terraform Cloud help you to collaborate on each step of your infrastructure development and deployment process. For example, each time if you plan a new change, your team can review that plan and your respective lead or approver can approve that plan so that that change will go into the respective environment. You can see it will automatically manage your TF state file. Okay, so it will automatically store your TF state file remotely on the cloud, and it will also lock it to prevent the concurrent modifications to the TF state file, which can lead to the corruptions. So you can see in the architecture, we have three types of workflow. The first one is CLI based. The second is UI based. And the third one is API based. So in the CLI driven workflow, it actually uses your standard CLI where you can run the Terraform plan, init, and apply commands. It will eventually run all this workflow on the Terraform cloud, but you can trigger from the CNI. Then we have a UI, or we call it as a VCS, version control system workflow, in which you can push your changes to your repository, and it will automatically trigger the associated workspace and workflows on the Terraform cloud. Then third, we have the API one. API-driven workflow, which allows you to create tooling to interact with the Terraform cloud with the API programmatically. And you can perform all these operations on different uh, target clouds. Maybe it can be Kubernetes, VMware, or AWS. Any kind of service provider, you can apply these changes through the Terraform cloud. Let's talk more about the AWS Service Catalog. So AWS Service Catalog lets you centrally manage your cloud resources to achieve the governance of the scale of your infrastructure as a code using the Terraform or the Cloud Formation templates. You can create, share, organize, and curate your IAC templates with the AWS Service Catalog. And we oftenly see customers are using AWS Service Catalog to create and manage their catalog of IT services, where we launch a product, we approve it, and then we share it with the end users to consume those products. So, what is a product? A product is an IT service that you want to make available for deployment on the AWS. A product can be consist of one or more AWS services, such as it can be EC2 instance, it can be a database, or it can be a storage volume, or it can be any network components, or it can be a complete AI solution. So that is the product. In the diagram, you can see we have two different roles, administrators and the developers, data scientists, and the other cloud consumers. So basically, we call it as a catalog administrator who actually manage all the catalogs and products centrally. It actually creates your CloudFormation templates or Terraform configurations. It manages it centrally. It also manage all your access controls, okay? IAM policies, roles on the specific product, who should consume your product, okay? And it also manages the control of your end users or consumers. Then we have the end users. It can be developers, data scientists, or any other cloud consumers. Uh, they will see the product based on their access level, and they can perform the limited operations on that product, whichever granted by the administrator. So the administrator actually create a portfolios and product, and then that publish to the different respective environments, and it will be appear as deployable artifacts in that specific environments to the end users. And then they can once they discover that product, they can provision that product, and they can consume and start building their infrastructure with that product. That's how AWS Service Catalog works. So with that, I will hand over to Ishwar to continue with the architecture, solution, and demonstration of the solution. Over to you, Ishwar. Thank you so much.
Awesome. Thank you, Dr. Rahul Gaikwad, for this great presentation. Hello, everyone. My name is Ishwar Sautawale. I'm a DevOps consultant in AWS. I have completed HashiCorp Terraform Associate certification, as well as I have completed 3 certifications in AWS Cloud Platform. So in this session, I will walk you through the architecture overview of this solution, followed by practical demo. So in this architecture overview, end user will start provisioning service catalog Terraform product type in the Spock account. In this example, let's suppose that the product type is Amazon S3. Then AWS Service Catalog send this request to Terraform Cloud Reference Engine via SQS. Then this request mostly contain the information about Terraform configuration file and the information about service catalog launch role constraint. Then this request is performed by the AWS Lambda function, Then Lambda will pass this to the Terraform cloud to perform the Terraform cloud workflows like Terraform apply, destroy, etc. Then Terraform cloud will authenticate with the Spoke account using the launch role to complete the product provisioning. Once this product is provisioned, Terraform Cloud will notify that provision result to the Terraform Cloud reference engine. Then finally, Terraform Cloud reference engine send that product provisioning event result to the AWS service catalog. And finally, our provision product will be ready to share and use. So this is the workflow of this solution architecture, and then we will go through the demo section. So let's go to the demo section now. Okay, so it's demo time. Before starting and running the demo, we will provide the few more information about the prerequisite. As a prerequisite, you will need active Terraform Cloud organization that supports the team management, as well as you will need AWS account for creating the AWS resources under it. Once you have those prerequisites ready, you can use this code base where we have main.tf file which is calling a two module. One is module related to setting up the Terraform Cloud uh, reference engine, and one module is related to setting up the sample AWS service catalog product. So before starting and running this code base, you need to make sure that you have updated your organization details under Terraform tfware file, as well as you updated your tfc team details in this file. Once you updated it, you also need to make sure that you have configured AWS credentials, as well as you have configured the Terraform Cloud token. So to configure AWS credentials, you need to run the Terraform configure command, and to configure the Terraform Cloud token, you need to run the Terraform login command. Once you are done with that, you can go to this directory and you can run the Terraform plan. Yeah, based on our configured token, this Terraform plan will prepare plan against this resource configuration. Same plan details we can see on in our organization. So you need to go to the organizations and you need to use your workspace and product. So this is the workspace we have. So let's use this workspace. It will once the plan is completed over here on the CLI, the same plan update we will see under the Terraform Cloud UI, because we have integrated it with the Terraform Cloud. So go to the runs, and here you can see the plan in queue. So once this plan is ready, we can check the update of that respective plan from the Terraform Cloud UI as well. So currently it is being planned against those resources. So once this Terraform plan is prepared, we will quickly review it and we will apply it. Yeah, plan is finished. The UI, yeah, plan is finished. The plan summary is 94 resources to be gonna to add, 0 to change, 0 to destroy. We will apply this plan. So this plan will so this Terraform configuration, as we mentioned, it will create the Terraform resources related to Terraform Cloud reference engine, and once that engine is ready, it will launch the AWS service catalog product using Terraform configuration. So plan is ready. We can go to the runs. We can see the next run. Plan is finished again about 0 minute. Now plan is in queue. Whenever we run the Terraform apply, internally it run the Terraform plan. So once this plan is ready, we will provide the confirmations to apply it. now base as we already integrated Terraform Cloud, so that is the reason we are able to see all the updates over here. So currently it is running the Terraform apply command, run operation in the Terraform Cloud workflow. It estimated the cost. We can see Terraform Cloud estimated the cost and it is asking for the confirmation. We'll provide the confirmation as yes. So apply is in queue. It started now. It started creating the resources. Same status we can check from the CLI. It completed few resources, creating it, completed after 0 second. So this run operation is creating the AWS resources against Terraform plan which we applied. Let's wait for a couple of seconds to get this completed. Once it is completed, we will see these resources and Terraform product on the AWS service catalog, from where we will launch this, share this product with the other hub account, and then we will launch that product, and we will see the back this product is launched in the Terraform Cloud organizations with the different product or the namespaces. Okay, so this Terraform apply is completed. Now you need to navigate to the AWS service catalog service. And here you need to go here under the administrative portfolio. In the portfolio we can see this product Terraform example, and this product type is Terraform Cloud. So once it is, so now the product is ready, we need to go here in the access, grant access. So currently we have the same AWS account, that is the reason we will grant to the demo user, but if you have hub and spoke account details, you can grant to the that respective account. So yeah, now it is granted, and yeah, let's log into the other user for which we have granted this product, and from there we will launch this product. So now I have logged into our Spock user for which we have shared the service catalog product. If we go to the product, we can see the product is here, the admin owner is admin, and the product type is Terraform Cloud. We can simply select it and launch it. Yeah, keep the default option, generate the name. If you want, you can experiment with the custom names or other parameters. Yeah, we started the provisioning the product. The currently product status is under change, Once it is completed, it will show the available, and once it is available, we should see that the S3 bucket got created with starting prefix. So yeah, let's wait for a couple of minutes. Yes, now we can see the product status is available, and if we refresh, go here S3 and refresh it, yeah, we can see our product has been deployed and S3 bucket got created. Okay, so that's it from this demo. Let's move to the next slide. Yeah, next slide we have is for call for action. We have given the useful link of the resources. Go through these links to understand more about Terraform Cloud, more about AWS Service Catalog, more about the integration of those services using this reference blog, which is very good. We have given the Git codebase repository details. Use this codebase to experiment and learn more. Yeah, that's it from the demo. We have completed the demo. Thank you everyone, thank you all. This is really pleasure to present this session at HashiTalk, and feel free to reach out to us on the given contact details if you face any issue or anything. Thank you.
Fantastic. Thank you so much, Rahul, and fantastic presentation. Loved the the demo again. Super detailed. The level of demos here today on the presentations has been supreme, and I appreciate the speakers. I can't believe we're halfway through HashiTalks India of this edition. So I'm really excited that we got to see so many good presentations today. I just wanted to say thank you to all, as this is where I'm going to leave you all, and I'll hand it over to our next MC. I just want to quickly say thank you to all the speakers. I loved hearing about the best practices and how to test infrastructure as code with Terraform. Love seeing some of the feature sets around Terraform Cloud. Again, it's free to try out for practitioners, and so please try it out. Awesome demos against AWS WAF and Service Catalog. Fantastic presentations. And lastly, awesome live demo on GitHub workflows that might have taken the cake for me. Again, thank you so much. And thank you for our producer, Jasmine, as well. And I'll see you all in the next edition. And with that, I'll hand it off to Madhu.
Thanks, Harry. Thank you. Thanks. You did a great job. Yeah, well done. Hi, morning or afternoon, everyone. My name is Madhu Kumar. I'm a HashiCorp user group leader based in Budapest. I'm also an AWS hero, and I'm active in other communities as well. So yeah, thanks Jasmine and HashiCorp community team for inviting me as MC. And yeah, so far the grade was great. I was following all the speakers, great talks. More to come. So yeah, stay tuned, don't miss it. So with that, I would like to introduce our next speaker. Prabhu Raghav, he's a co-founder and CTO for a data science and generative AI product company. He specialized in core technologies, ML, AI, algorithms, cloud services, and expertise in research-driven developments in the new edge technologies. So welcome, Prabhu. Stage is all yours.
Hello, everyone. Good morning, good afternoon, good evening, wherever you are. I'm thrilled to have everyone joined here for the wonderful session hosted by HashiTalks. So, further ado, let's get started. So, in this session, what you're going to explain is how we are using a HashiCorp Packer in our data science product called Decision Facts. So really the HashiCorp Packer with using in our product, it saves a lot of time. And in the slides, I'm going to explain what are the features that we are using and how we are solving uh, uh, the time and the complexities with the help of a Packer in our data science product. So let's get started. Just a quick introduction about me. So this is Prabhu Raghav. I'm co-founder and CTO of Decision Facts, and I'm predominantly working on the data science product called Decision Facts, and more focusing on the technology and the research-driven approach model that we are taking in this product. And a quick talk about our product. So our Decision Facts is a B2B SaaS platform, which offering many platform as a service, model as a service, and AI based LLM as a service. All these features that we are providing via our Decision Facts platform. So for the foundational thing is what we are using here is a Kubernetes containers and the VM images. That's a foundational thing that we are using, and also we are a cloud agnostic. So with the help of a Packer, these images we build in automated mode, and it's deployed into our platform and the customer's platform. Everything managed via this Packer. So that's a we thought, okay, this is the best use case that we can present into the HashiTalk with the tool. So that's what I'm going to explain here. So as I said, in our product, what we have is a model building as a service. So model building as a service, basically, we have an inbuilt Jupyter notebook, and it enables with various data connectors like SAP, Google BigQuery, Redshift, Postgres, MySQL, MongoDB, many connectors we have. So all these connectors and the integrated with this notebook, we have a different runtimes. The runtime is nothing but Python 3.9, 3.10, Spark, and extracting the content from various sites or various source of documents. Basically, that is bundled inside the container image that is called spider. So all these images that we are building with the help of a Packer. That the once they open the notebook and then they connect to a Kubernetes running cluster, this container image will be in a running mode, and then it will connect. And then, for example, if you want to connect to a Snowflake connector, in this notebook you can write a code, and the Snowflake connector will be established to the Snowflake instance, and then get the details, read and write, all the operations will be done. So with the help of this Packer, this our framework and the connector components, everything will be pre-installed, so that the users can choose the runtime like a Python 3.9 or 3.10, and they can choose and launch. So this is what the model building as a service. And the advanced analytical as a service is nothing but a scenario tracking. So this predominantly we are cloud agnostic. We are using AWS, Google, and Azure. So all these images are pre-bundled with our agent code. That agent code is basically look for the notebook, whatever people submit, and then it will process it in a batch mode, and the output will be written into back to our storage, or it will be writing into the users that they want to write it on their APIs or their database. Everything it is possible. So all this agent code and this connector, everything will be pre-bundled in the image. That image what we are using here is going to launch, and is basically it will provide a digital twin and the scenario tracking components. Everything will be provided from here, advanced analytical as a service. When coming back to AI based application service, so with the latest trend, the LLMs, large language models, and the custom models, all the models like Hugging Face models, all the models what we are supporting, they can build a rack system, or they can build any prediction, or they can build their own large language model as a service. All this thing can be built by using our platform. Again, this fundamental building this application by using a AI based application. This images, this VM image like in AWS, Amazon Machine image, or a Google image, or a Azure image, all this will have the base component, which will when they choose a Hugging Face, let's say they want to Llama 2 want to launch 13B or 7B, or any other Mistral or any other LLM that they want to choose, they can select the LLM, and then they can deploy. So what happens? This by getting this parameter, that VM will be launched in a GPU, and then it will deploy, and it will provide you an LLM service endpoint. That endpoint can be used in rack system or any other systems that the users want to build into their custom use cases. So further, this VM images all built with our predefined agent and the component. With the help of a packer, we build this one. So again, if you see on a high-level blueprint of our architecture, in the bottom layer is a compute on any cloud, Azure, AWS, and Google, and any data that we support, any data sources that we connect, or any type of model. So that is the underlying layer. On top is a important layer is VM images and container images. That is the one going to execute the jobs and process the input and perform other operations and then write it back into storage. All this requires VM images and the container images that will pre-bundle with our agent code and the components. So on top of it, there's in fact engine, that is the controller, the API layer, and the user interface. All it's connected to the runtime images that the customer going to launch. So this is a high level our the architecture here. As I explained, model building as a service. So whenever, let's say if you launch a Python 3.9 or 3.10 or Spark or any other custom models or custom containers that the user wants to connect with their notebook in our platform. So we build these images. So we completely automated thing by using a packer and with the help of AWS code build. The reason we use a AWS code build is we have started with AWS cloud first. So the code build automation we have established. So then with the help of a packer, the building images earlier, what we did is manually building image and uploading into AMI and then sharing this machine images to other customer accounts. So what we did is with using HashiCorp Packer, in a single click, it pulled the latest code from our GitHub repository and then build the image and then publish the machine images into our private AMI, and then it will send the notification to our the backend portal. And then in the backend portal, our moderator or a platform admin will be able to share our machine images to the customer accounts. So this is the process. So we bundle the agent, create a image with the help of a packer, the container image here in the Kubernetes, and then we launch it. And the next one is a advanced analytic as a service. It's like a simulation thing. So any models like a forecasting or any predictions or any kind of a model so basically our platform, the core platform is what supporting simulation model. So based on the simulation, the customer can make a decision. So which model is doing a good, which one is providing high accuracy. So for this models has to be built and executed. In order to do that, the foundational thing is VM images or the containers, right? So the VM images and the containers all pre-bundled with our agent module. So the agent module, when it launches as an virtual machine image, virtual machine instance, it will look for the instruction from our backend controller. So backend controller will send the instructions. Let's say, hey, run this notebook, connect to this data source, and pull the data, process it, massage it, and then send it back to storage bag, or send it to the configured API or any other external data source that the customer connected. Everything will be configured in this user interface, and then they can run it. So they can run with various simulations. Our customers are more running multiple simulations. In order to do that, the same machine images or the containers has to be used in the same version. So that's a packer we build. With the help of a packer, we build this advanced analytics as a service. Now another interesting service what we are it's currently in alpha version. We yet to release for the public usability. So what we are building is a LLM as a service, basically large language model as a service. Since our base framework have a option to bring your own cloud concept, They can configure their own cloud, and then this the images what we built by with the help of Packer, that will be shared onto their customer account, and then they can select any ML models like Llama 2, Mistral, or if they have any TensorFlow or PyTorch model, all have the foundational framework is built inside the image, and then from our user interface they can select and run it. So when the moment they run it, they can provide certain parameters, and then once it's launched, it will provide you an restful endpoint with the authenticated token. So that endpoint can be configured. Let's say if I'm building a RAG system with a vector DB search, if I'm building a RAG system, this LLM service can be configured so that when they index their content, PDF, document, or images, even any other sources that they extract and index it into vector DB, when they ask the question in a natural language mode, it will go and retrieve the vector data, and then with the help of LLM, it will give you a summarized result. So not to give that, the LLM is a core component here. By using the LLM service, our model as a service uh, feature will provide you an option to create as an endpoint, so that that endpoint can be configured. Not only that, let's say there some of the enterprise customers, they want to train their own data set. All things can be done, and then they can publish their own models within the private or a public in the Hugging Face. All this can be done like training a model or fine tuning a model with the prompt engineering. All these things are this the fundamental components is pre-installed in our machine images, that will be that is shared across the customer accounts. So they will be launching, and they will be using uh, these services, and they can get us an RESTful endpoints. So this is the blueprint of the flow, how decision facts deployment management that we are using with the help of a Packer. So let's say our engineering team develop or enable the feature, and then we created a deployment tags. When the moment deployment tags received, the event trigger notification comes into AWS code build and pipeline. Code build will pull the image, pull the data from the tag, and then with the help of a Packer, it will build an image. The image could be a container image or the VM images. So the container image built, it will the images will be published into our GitHub images repository. If it is an image, if it is an virtual machine images with the using a Packer, it will be created a private machine images onto the respective clouds. So once this image is built, if you see the flow, the trigger, the first point is deployment tags event trigger, and then AWS code build and code pipeline get the notification. In our build spec YAML file, we have a Packer component. The Packer component build the image, and based on the instructions, either it's a container image want to build, or a virtual image in AWS, Google, Azure. In future, we are going to support other clouds as well. So this images will be built, and once the image is built, and then the status notification will be sent to our engine, so that it will be notified to the our administrator or the moderators, who can verify, and then they can take action. They take an action in the sense to share these images, or announce this images is available. All this activities will be done by the moderator. So this is a small snippet in the build spec YAML what we are using. So build spec YAML. So first in AWS, with the help of secret manager, we have a AWS access key and secret key. This is our platform access key and secret key. And on the next phase in the install component, it will installing the Packer. So the Packer component will be pulled from the public repository, public source, and then it install inside the event in the machine image. And once it's done, then sorry, let's And then in the building section, the AWS access key and secret key will be set in the environment variable, and then set the Packer plugins if it is required. And in our uh, component, we have a HCL files. That HCL files have instruction. Let's say if you want to build a AWS image, uh, what all the shell scripts needs to be pulled from the repository, and in the shell script we have a various instructions like to pull the code and set the components and configure these files and build the image. So all this in the shell script. With the help of Packer, these images will be built and it will be stored into our private Amazon machine image. If it is in Google, so we pass the Google key as a parameter into the via secret manager, and the same thing, the Packer will be installed, and the Google application credentials will be as a environment variable here, and then it will install the Google Compute plugin for Packer in order to build the VM images. And in our HCL file for a GCP, we have instructions what needs to be done. That will be executed here. Similar way for Azure also we have. So the same procedures we follow, and the Azure images will be built. So when we build the images, these images will not directly go to the customer account. It will be into our cloud account. So once the sanity check everything is done, then we will share this private machine images to the customers on need basis. Okay. Having said that, what are the benefits with by using a Packer in our design facts? Let's see. So as I explained in the previous slides, our design facts runtimes, either in the machine image or containers, we have a Python, Spark, and various SDKs and the connectors like Snowflake, Redshift. Any all the connectors are pre-bundled. Pre-bundled not with the credentials, but the base framework is pre-bundled. So from the user interface, the customers or the users can select what connectors needs to be selected in order to pull the data, or if you want to write the data back after my model is completed the process and then gives some output result. So those are all, everything is a seamless mode. In order to do that, these components, the basic, the the um, the full flow data components and the agents, everything needs to be pre-bundled inside the machine image. So that's what we build inside the container image or the virtual machine image. So in our DevOps workflow, earlier before Packer, what we did is everything is a manual thing. We manually launch a machine image. For example, if it is an AWS, we launch a machine image and then we do all the security and hardening things. And then inside the machine image, we pull the GitHub code and manually configure everything. And from the respective clouds, we right click and create image, right? So that's what we did earlier. But with the help of Packer, our DevOps team is so happy, and with a single click, these images and the container images all we build within a fraction of a second. So because the manual thing is going to take time, and if there are many areas that human errors also we faced earlier. So now it's the human errors are completely reduced here, and with the AWS code build and code deploy, this Packer, with the help of Packer tool, we completely automate things. When a GitHub get the sends a event notification like tagging, this CI/CD pipeline automatically trigger and build the images or the containers. So yeah, that's all I mean. And thank you for everyone to join here and see this the flow. Thank you.
Cool. Thanks, Prabhu. That was a great talk. I think, yeah, that this AI, ML, Gen AI, so much going on. AWS launched Party Rock last 2 weeks, in the reInvent. Google coming out, is Gemini. ChatGPT 5 in the pipeline. I think we're going to see more advanced LLMs, large language models, progress. So I'm looking forward to see what's in the what's going to come up in the future. So cool. With that, I think I'm checking for any questions in the chat. If there are no, then I would like to thanks Prabhu again. That was a great talk. I would like to introduce our next speaker, Anupam Phogat. Is a seasoned IT professional with years of experience in the field. He's also an extensive, user of the cloud, a hyperscaler with the GP Google Cloud Platform, and he currently holds a professional level Google Cloud certification, and also is a container expert with certified Kubernetes and deep understanding on core concepts of Kubernetes. He's also passionate about sharing knowledge with others by actually participating in the Google GCP community, and it helps his own learning and growth in this field. So that's all this all about community about, right? So with that, I welcome Anupam on the stage, and stage is all yours, Anupam.
Madhu. Thank you so much for being here. We're actually a little bit early, so we
Oh, all
have.
right. Sorry, I haven't seen it. Okay.
It's okay. It's okay. We have a treat for everyone. And before I do that, let me just say hi to everyone. Hi to our community in India and everyone else who's watching. I rarely come on the screen because I'm always behind I'm behind the screen doing all the producing to try and make it seamless. Um, but I think what we're going to do is we have a treat in that we're going to show a video that all of these videos are going to be on YouTube at a later date so that you all have an opportunity to rewatch them just in case you miss anything, because this is a long event. People have work to do, they have families, they have other obligations. So, what we do is we put it on a playlist, and you can check back at that playlist. It should be up within a week's time so that you can review all these videos. So what we're going to do is we are going to play a video that was at HashiTalks India last year so that you can see how the tools are still relevant or how they may have changed. And then once this video is over, we will then be able to welcome Anubam. Hopefully, they'll be here by then and we can continue. So, just give us a moment and we will have that video ready.
Yeah, now that we're in your spotlight, Jasmine, I also would like to say to the viewers that Jasmine is really working hard. I mean, I don't know if you guys noticed, she's from the East Coast, so she joined. I think it's 24/7. I don't know how many hours you're working on, but yeah, I really appreciate that, Jasmine, and yeah, her community. Yeah, you really take it serious on this community side, and I really appreciate that.
Yeah, I really do love this community. I'm very much so inspired by all of you and everything that you do, especially with the HashiCorp user groups. Every time I was able to see you at reInvent and so many of our other community members at reInvent, and every time I meet a community member in person, I just feel reinvigorated. Like you all just are my motivation, and you help me to want to do more. So I'm just really excited to do all that I can for you all.
Thanks for all that you do, Jasmine.
Yes. Okay, so I have the video and I am going to take us off, and then we will play. This is going to be Abhishek Dubey, who spoke last year on managing Windows-based microservices using Nomad. And I really do like Nomad talks. So we'll play this and then we'll be back on schedule with our next speaker. So stay tuned, everybody.
Hari, thank you for that warm introduction. I hope my screen is visible. I'm sharing my slides. Yeah. So, guys, hey, hi everyone. So, today we are going to talk about managing the different types of window microservices using Nomad. I know people have a different perception about the orchestration services. A lot of people use Kubernetes and all, but here I want to give a different view of Nomad, which I get to learn about while doing an interesting project. So again, my introduction has been already in my hurry. So I'm a DevOps consultant working with Opsi Solution. I'm a technology enthusiast, and I'm an open source contributor as well. I do contribution in HashiCorp projects and the projects like Kubernetes, Prometheus. So I'm one of the developers on those projects as well. So that's it about me. Yeah. Here, before going to the main part of the Nomad orchestration using the Windows microservices, here I want to give a little walkthrough of the Nomad as an orchestration engine. So I guess a lot of people already have the context around it, but I just want to give a little bit of glimpse of it. So basically, HashiCorp Nomad is an orchestration platform which can manage a microservices environment and which can manage a complex microservices environments very easily. And one of the very good benefit of using the Nomad is that you are not restricted to use only containerized applications. So while other orchestrators are limited to the using the containerized applications and all, you can run non-containerized applications as well using the Nomad. It can run used for the running the deployments. It can be used for running the batch jobs and many other purposes as well. Also, Nomad comes with another beautiful product of HashiCorp, which is called Console. So you can integrate Nomad and Console, and through that you can achieve the service mesh and the other features of it. Other than that, Nomad is a cross-platform. Since it's written in Golang and designed in Golang, it can support the different platforms as well. So, for example, you want it run on a Mac OS system, you want to run it on a Windows system, you want to run it on a Linux system, you don't have to worry about it. You can run it very easily. Now, next question is that when we already have a lot of orchestrators available in the market, why do we need Nomad? So one thing is that I love about the technologies which enables the plugin mechanism, where we have our own custom plugin and we can club it to the main system and we can do anything about it. So for example, that is one philosophy on Nomad is based on. So basically it is not restricted to running the microservices on the container basis. For example, you would directly want to run the Java applications. You can integrate the Java plugin with the Nomad and you can run the Java application. And let's say you want to do the virtual machine management using the Firecracker, you can integrate that. And other than that, Nomad provides an extension point in terms of the custom plugins where you can write your own custom plugin, which we have done so far. And you can integrate that custom plugin to the Nomad, and then you can leverage the functionalities of the Nomad. So that's what we did with our project, which we are going to explain in the further slides. Now, again, another reason of using the Nomad is that while the other orchestrator have this little bit dependency on the Linux operating system and they work great with the Linux operating system, but for the other operating system, they are still in the development phase and they are evolving. But the one thing is the Nomad is that, again, we have explained that it's a cross-platform binary which can run on any kind of system. So for example, here, if you see that our Nomad and Console server is running on the Linux platforms, but you can run the Nomad clients on the Windows platform as well. Since it's a OS independent project, so you can install it on the any kind of operating system, any kind of architecture. It's not only always restricted to AMD kind of architecture. You can run it on ARM based system. You can run it on over a Raspberry Pi system as well. So that is also a possibility which we have with the Nomad. So that's a really cool thing about the Nomad. And these are some other reasons which are already part of the a basic orchestrator functionality, that Nomad supports the auto scaling. And it not only supports the auto scaling, it also supports the integration with the different metric system. For example, you can integrate your Nomad with some other monitoring system. For example, you can integrate with the Datadog, we can integrate it with the Prometheus, and from the metrics calculation, you can do the auto scaling. So for example, whatever the metrics we are getting on the basis of threshold, I want to do the auto scaling. I can easily do the auto scaling using the Nomad with the other projects. And the failover part is also there. So one thing with the orchestration engine is that once my application is ready and running, then only it should serve the request. And if it is not ready, it should not serve the request. So that's the bare minimum functionality which orchestration engine should support, and that is already supported by the Nomad. So let's say if I have a set of microservices running, and let's say, and those microservices have different replicas, so let's say 5 or 10 replicas of those microservices, and on the basis of that, basically in between those 5 to 10 replicas, 2 replicas are not responding. So the orchestration engine will not send any kind of incoming request to those systems. It will send the request only to the healthy system. So that is the failover is also the part of the Nomad orchestration engine. Then metrics monitoring. So basically Nomad has a it's a direct instrumented project with the Prometheus. So basically, when we say directly instrumented services, in that case, you don't even have to install the agent. For example, I directly want to monitor the Nomad and then let's say console to the Prometheus. I don't have to install any kind of agent. I just have to enable some specific configuration. And after that, I'll be able to monitor the complete platform on the Prometheus like system. And let's say if we don't want to use Prometheus and we want to use some other metrics monitoring system, in that case as well, we are not restricted by the functionality. You have different agent available for the Nomad monitoring, which you can install, and you can monitor your complete Nomad cluster. For example, you can monitor it over the Datadog, Dynatrace, other monitoring system. Then service discovery. So service discovery is not technically the part of the Nomad service. Nomad directly does not support the service discovery. You have to integrate the HashiCorp product, which is called Console, which is specially built for the service mesh and the service discovery concept. So basically, you can integrate the Console with the Nomad, and through that, you can achieve the service discovery between your microservices inside the Nomad cluster. And then nowadays, this is a very popular concept of the service mesh, where we have to create end-to-end encryption connection between two services. So basically, that is also one of the things which Nomad is supporting with the help of Console. And with the Console Connect, we can install the Envoy proxy as a sidecar, and that can help the microservices talk to each other in a secure fashion. So service mesh and the service observability is also one of the things which is supported by the Nomad large widely on the complete cluster. Now, this is the main agenda which we wanted to talk on. So basically, the major problem statement that we have while working on something, that we had a project called a traveling site. And on that traveling site, the thing was that they were running the major applications on the .NET applications. And it was not .NET Core 5, so that was they were managing over the Kubernetes and other platform, but they had a large chunk of applications on the .NET applications, and those applications were running on the static Windows instances. But the challenges with the static Windows instances were a lot. First thing, that we did not have the scaling, because those were static instances, so scaling and downscaling is something which was not part of the scope. The failover, whatever the thing which we have mentioned on the previous slide, that was something which we were not able to do on the Windows-based microservices. And since they were using Kubernetes and orchestration engine, they did not give a thought about some other thing. But while working on the Nomad, I came across this amazing concept of the plugins. And so what exactly we did as a solution, we identified a plugin which is supporting the IES drivers of the Windows, which is called the Nomad Driver IES, which is created by a Roblox organization. And we forked that project, and we did the further development on it. So what exactly Nomad supports, that you can create any kind of custom plugin and you can integrate it with the Nomad system. And once you integrate it with the Nomad system, in that case, you can leverage the Nomad functionalities with those plugins. So this is what we wanted to do. So what we did, we took this Windows IES plugin, which was open source, we customized it, and we integrated with the Nomad system, so that we can take the leverage of Nomad system. And after that, whatever the .NET based applications we had, we were able to manage those .NET applications using the Nomad platform very easily. Now, this was the solution architecture we had while working on this particular project, that over the period of time, we completely migrated to the orchestration engine as Nomad, because here we did not have the complexity of managing the two different orchestration engines. A single orchestration engine was able to support our both functionalities, where we have to run some Dockerized applications, and another use case was running some custom applications of the IES sites, which is based on the .NET based application. So what exactly we did, we created the pool of 3 Nomad leaders, and on the basis of that, we integrated the console servers. And after that, we added the agent to that Nomad leader pool. Now, in that case, we have a Linux follower, we have a Windows follower, and we divided it. So basically, whatever the applications which were running on the Docker engine, we were targeting for the Linux follower. So all the Dockerized applications were running on the Linux follower pool. Then whatever the applications, we have the .NET based applications and we wanted to run it over the Windows platform, we installed our custom plugin on those nodes, and we targeted all the Windows based applications on that particular node pool. In that case, a single orchestration engine was able to support our both use cases. We were able to run the .NET based applications, which is completely restricted to the Windows, and we were able to run the Dockerized applications using the Linux followers as well. So that is the solution architecture we came upon on using the Nomad orchestration engine. Now, the question is that how did we able to enable that custom plugin? So basically, Nomad provides you the some set of configuration where you have this functionality. You can enable your own custom plugin. So basically, you see that I have highlighted this particular area where I can define that this is my plugin directory and where I can store my plugin. And once we have stored that plugin, the Nomad will automatically pick it. And after that, whenever you have installed the plugin, you have to enable it, because by default the plugins are disabled in the Nomad. And whenever you are integrating a custom plugin, or let's say the existing plugin which is supported by the Nomad, you have to enable it. So here we have enabled the plugin called WinIS, which means Windows IS system, and then we have enabled the configurations. And once we have done this, that's it. Our Nomad platform is able to run the .NET based applications on the IS sites very easily and without any challenges. Now, this is something which is interesting here. So basically, we have the job and task, and on the basis of this job and task, we have like a definition of the job and task of the IES configuration. So basically, if you see here, we have created our own custom block inside the Nomad, which is called this config block. So this is something which we have as a generic block inside the Nomad, where you have to define the name of the job, you have to define the data center, then you have to define the type of service, and you define the count. This is something which is a generic concept of Nomad and supported in all plugins. And again, this is also something task set which is enabled, which is restricted to this custom plugin only. So basically, in the task, you have to define the driver which you are using. So for example, if I'm running a Docker based application, I say that in the driver I want to use Docker, and then I define the configurations related to Docker. But here I'm using the IS as a custom plugin. So I say that this is my driver and this is my artifact. So artifact is something where we have to provide that the application which we want to deploy, and I'm providing the driver. And once I have defined this, there's a configuration block. Now this configuration block is something which will always update on the basis of driver. So let's say in my case, the driver is Windows IES. And according to that, I have to define my configuration related to IS configuration, where we have defined the path where my application will be running. The application pool identity. This is something the IS property which we have to define, that I want to use the network service, I want to use some other IS property. And let's say the bindings. What should be your bindings? The type of bindings. For example, the application is running in the HTTP form, or is it running on the TCP form, and the label of the port, something like that. And let's say if the driver was Docker, we have updated the configuration. We have to update the configuration related to the Docker part. But since we are running the custom plugin, WinIS, accordingly we have defined the configuration here, and that's it. Once we have defined the task definition of the complete job of the Nomad task, we will have a picture like this. So basically, the allocation will be starting running on the Nomad cluster, where you see that my two IIS applications are running here, and those are being registered on the console server. So if we want to identify these things, we can easily see that whatever the services that being are created on the Nomad, that are being also registered on the console as well. And you can see that this is registered via Nomad is already highlighted here. So basically, this is how a single platform we use to manage all type of application, whether it's a Linux-based microservices, whether it's a Windows-based microservices, we were able to manage very easily on the Nomad platform. Now, let's say if you want to simulate this complete environment, what exactly we have done. Let me share again another tab of complete screen. Let me share it. Yeah. I think you will be able to see my entire screen now. On the entire screen, now you can see this is a project which we have prepared, which we already have mentioned on the particularly slides as well. On the slides as well, I have shared the link of it. So this is the Nomad driver IES plugin, which have the complete simulation of it. So basically it's a Go plugin which can be compiled and stored inside the client machine, and then you can run it. So basically, to simulate this particular project, I have created a Vagrant project. So basically this Vagrant project is something which can be used to run the complete application. So basically you don't have to do anything. There is a Vagrant file present here which can do the complete simulation of the project, where you want to run a Nomad server, a Nomad client, a console server, and it can install the plugin as well, and it can run your application as well. So basically this Vagrant is also one of the HashiCorp project which we have used. It will use a Windows image, and on the basis of the Windows image, it will install all the necessary thing. For example, if I go to the scripts part, I'll explain it here. It is using a PowerShell script where it will install the Git, Golang, console, Nomad, and after that it will creating the services and all. So once this has been created, your Nomad and console service will be running on the same system. And then once it is ready, you have the example folder here, and inside the example folder you have the IAS test Nomad, where the complete example is available, where you can define this complete data centers type, count, and the restart details. Then you have the drive task. In the task you have defined the driver equals to WinIAS, and then we have defined the source artifact. So this is a sample.NET based application project which I have already uploaded so that people can test it. And then in the config path we are defining the IS related configuration that I want to use. Netcore app is the application name, and this is the task directory. It is available here. And then we have the app pool identity. We are defining the network service bindings, and this was something which was not supported by default inside the this IS driver plugin. That's why we have forked in and we added this customization. So basically now it is supporting the resources block as well. So CPU memory can also be restricted for a process. So basically it's nothing like that. You can run the service and that service can choke up complete CPU and memory of a system. You can always restrict that process in terms of CPU memory. So that is also one of the functionality which we have added here. Then we have the service block, which is registering all these services to the console system. So if you want to try this complete simulation, please go through this project. Please try to simulate it. And let's say if you face any issues, you can open the GitHub issues and I'll try to fix those things. But yeah, I have already tested this project multiple times. I use it for my development. So I really doubt how it will show any issues. But let's say if you want to see how exactly we can build this, there's a documentation available in the form of um, particularly markdown format, the readme format. So in the readme we have defined how you can build the plugin, how you can configure it, and how you can run your job. So all the things are in place in the terms of readme file. So do check out this project and let us know that if you face any issues and all. Now, again, I would like to do the summarize of the complete things which we have explained till now. So basically, a lot of people have this perception that when we talk about the orchestration, they think about Kubernetes is the only orchestration engine available right now in the market, which is super successful and can run all kind of microservices. But there are few things for which we can always leverage orchestration in systems like Nomad. So for example, here we have a custom plugin requirement where we have the Windows-based applications and we cannot run it on the Kubernetes. The reason was that the Kubernetes is not that much stable on the Windows side, and we identified that Nomad is something which is supported on all type of platform, and we can leverage that. So we decided to go with the custom plugin. We integrated that custom plugin inside the Nomad, and we were able to run all the Windows-based microservices, which we were not able to do that. And once we integrated this system, we have the functionalities of auto scaling, failover, and all those things of a basic orchestration engine inside our applications. And right now we are running around 250 microservices over this Nomad platform on the Windows part. Particularly the Linux is different, but Windows microservices, we are running around 250 microservices using this particular plugin and the Nomad platform. So that is one of the thing which we talk about. So basically you can always look for a better alternative rather than relying on the popular solution, which can provide you the more suitable functionalities related to your system. So that is something which we have done with the Nomad. So yeah, that's it from my side. If you guys have any questions, please let us know.
Oh, Madhu, you are muted.
Oh, sorry. Thanks, thanks, Jasmine. Just a typical thing on a live event, right? So, sorry, that was a great talk on Nomad. If anybody wants to reach out on the more detail on this question, so yeah, we can. Yeah, I just sent the use cases for Nomad, so just you can go through that, and we can come back to your question, Yash. Cool. Let's then get the ball rolling, and I'd like to introduce our next speaker, Anupam Phogat, the seasoned IT professional and years of experience in this IT, and also extensive experience on Google Cloud Platform, and currently holds a professional certificate on GCP as well. So he's also a certified Kubernetes expert and deep understanding and core concepts of Kubernetes. So I would like to invite Anupam to the stage. Stage is all yours, Anu.
Thank you, Madhu. Really appreciate it. Good afternoon or good evening, everyone, depending on your geographical location. Thanks for being here today. In this rapidly evolving digital era, businesses are continuously seeking ways to leverage modern technologies to enhance their efficiency, stay competitive, and accelerate their growth. A pivotal aspect of this transformation is digital modernization. Today, we embark on a journey into the realm of digital modernization on Google Cloud Platform, examining its three facets, including application modernization, infrastructure modernization, and data modernization. We'll also look into the strategic use of Terraform and Pagure, crafting a resilient platform that empowers us to unlock the complete capabilities of the public cloud through streamlined deployment and resource reapplication. Now, as we embark on our exploration of digital modernization, it's crucial to dispel the misconception that it's merely the migration to the cloud. So the landscape of modernization extends beyond a simple relocation to the cloud. It encompasses a holistic transformation that integrates three essential elements: application, infrastructure, and data. These three facets synergize to form the comprehensive concept of digital modernization. Let's break it down further. So application modernization basically involves optimizing and enhancing existing applications, making them cloud native, scalable, and agile. Simultaneously, infrastructure modernization focuses on refining the underlying IT infrastructure to harness the full potential of cloud resources. Finally, data modernization addresses the strategic management and utilization of data, ensuring that it becomes a valuable asset to form decision making. Together, these interconnected concepts redefine the digital landscape, creating a symbiotic relationship that goes beyond simple migration. It is a transformative journey towards digital modernization. So remember, in this equation, the combined force of application modernization, infrastructure modernization, and data modernization provides the true essence of digital modernization. Now, before we embark on our journey to talk about the digital modernization in more detail, let me touch upon a little bit about my background. So my name is Anu. I'm a principal consultant with a strong focus on cloud technologies. I have a passion for delivering innovative solutions. I specialize in Google Cloud Platform with strong emphasis on professional development. I've got 15 years of industry experience, and I've got many professional level certifications. I currently hold 9 out of 11 Google Cloud professional certifications and aiming to achieve that magical number of 11 soon. I regularly contribute to blog posts and participate in boot camps where I can engage with other cloud enthusiasts and technical people out there, gain insights from their experiences. Furthermore, I actively contribute to the growth of the GCP cloud community by actively participating as a member to foster collaboration and support others on their cloud journeys. And just a small note, I'm also a Google Cloud authorized trainer. So when we talk about modernization, we hear from everyone, be it the vendors or the customers, there are so many benefits of modernizing an application. Benefits such as increased agility and scalability, reduced costs, improved security, enhanced user experience, increased on innovation, and the list goes on. So the cloud-based applications are much more agile and scalable than the traditional on-premises applications. Cloud-based applications can help business to reduce their IT costs by eliminating the need to purchase and maintain on-premises hardware and software. Cloud platforms also offer a number of security and compliance features that can help businesses to protect their data and applications, provided it has been configured correctly. Now, before we start talking about modernization, let's just clarify the concept of what digital modernization actually is. I personally think it is the process of harnessing advanced technologies and platforms to transform your IT infrastructure, data management, and application development. In the context of Google Cloud Platform or any other cloud platform for that matter, we'll break it down into three core concepts or three core categories as we just touched upon. So first, infrastructure modernization. I believe it is the foundation of any digital transformation within a business. It is basically the process of transitioning from legacy on-premises infrastructure to agile, scalable, and cloud-based solutions. Whereas data modernization, it is basically the process of unlocking the value of data through cloud-based storage and processing capabilities, empowering advanced analytics, real-time insights, and intelligent decision-making solutions. Whereas application modernization as such is the process of updating application architecture, design, or functionality of the application altogether to leverage new technologies and cloud platforms by enhancing scalability, agility, and user experience. If we go a bit deeper for infrastructure modernization, it basically forms the bedrock of the digital transformation. It is the first step towards the digital modernization for any business. It involves migrating from traditional on-premises setups to dynamic cloud-based infrastructure. It refers to the process of updating and migrating an organization's IT infrastructure to the cloud. This can involve moving servers, storage, networking to the cloud, as well as adopting cloud-native technologies such as containerization and serverless computing. So just to highlight some key elements that include infrastructure modernization. First one is virtualization and containerization, which is basically utilizing tools like Kubernetes and Compute Engine for scalability, portability, and efficiency with some powerful code-based tools like Terraform. It comes hand in hand with infrastructure as a code, which is basically automating your infrastructure provisioning and management. You can also improve the security posture of your compute engines by utilizing tools like Pagure that you can utilize to create the images based on your own security standards. Then we have the next generation, which is, again, the serverless computing, the powerful services from the public cloud providers, leveraging services like Cloud Run or Cloud Functions for automatic scaling and cost efficiency. So you are not charged for any infrastructure that is not being run when there is no process running in the background. From a networking modernization's perspective, Google Cloud's high-performance network infrastructure for fast, secure, and globally connected applications. Now, if we talk about the data modernization, as we all know, data is a very valuable asset, and modernizing data management unlocks its potential. So data modernization refers to the process of updating and migrating an organization's data to the cloud. This can involve moving data from on-premises data centers to cloud-based data lakes and warehouse solutions, as well as adopting cloud-based data processing and analytics tools. Some of the key aspects in data modernization include data warehousing, as we just touched upon, migrating to the solutions like BigQuery for handling large volumes of structured and semi-structured data, data lakes and analytics for storing, managing, and analyzing diverse data types using cloud storage, data flow, or data prop. Again, data streaming and real-time analytics, and using machine learning and AI services for harnessing AI services like AutoML, AI platform, and TensorFlow for innovation and efficiency. Now, if I talk specifically about application modernization, as I was talking about, application modernization is more about than just migrating to the cloud. It is about enhancing applications architecture and improving the functionality, providing that efficiency to run the application efficiently, and that too at a lower cost, so to say. So the key components of application modernization include microservices architecture, which is basically breaking down the monolithic applications into microservices for agility, scalability, and independent deployment. And that's where tools like Terraform, which we use for infrastructure as a code, comes very handy. We also have API-based integration, fostering interoperability through seamless integration with other applications and systems. We have DevOps and CI/CD services, embracing DevOps practices and CI/CD pipelines for automated builds, testing, and deployment with very minimal manual intervention. Employ something like domain-driven design. If the core business runs via domain, so like a banking domain or telco, for example, decouple the application from any specific technology, which can basically fairly easily move from one database to another database without tying back to a particular platform or a technology. And one of the main aspect of application modernization is isolation of the business logic from technology. So there should not be a tight integration between the business logic and the technology that it is running on. If I go back a little bit, and when we talk about migration, as I was saying, that infrastructure modernization is basically the first step towards digital modernization. So whenever we talk about migration to the cloud, there are always 6 R's that we talk about. And some, again, depending on which cloud platform you are using, you might sometimes see 5 R's or 7 R's. But on a very high level, roughly there are like 6 R's, which is retire, retain, rehost, replatform, repurchase, and the 6th one is re-architect or refactor. So what is retire? Retire is after application discovery. You decide that you don't need these applications in the future. So you are just going to retire them. You are not taking that pain of migrating it to the cloud or doing the assessment of the complexity of migrating that application. You just think it's not needed and you just retire it. This is just getting rid of them as you are not going to use them anymore. With retain, you can decide to keep applications exactly as is before a re-evaluation sometime in the future. So you are not touching the application. Some of the common examples can be unsupported OS or application, legacy applications that do not have a business justification for migrating to the cloud. Then comes the third R, which is rehost. That is the fundamental step towards the migration to the cloud or towards the modernization journey. One of the most basic ways of migrating to the cloud is simply to rehost something, and that is something, it is also sometimes called as lift and shift. This means to take your applications or systems and move them as is into the cloud environment. This approach is great for organizations that need to migrate quickly. For example, data center lease is about to expire. Then we come to re-platform. So re-platform, which is sometimes also called as lift and reshape, because you can potentially take advantage of some of the special capabilities of the cloud. An example of this application migration strategy would be re-platforming leads to cloud optimization due to some cloud platform adoption while keeping the application core architecture the same. Often, replatforming is used when you're replacing a database backends for applications with corresponding platform as a service database solutions of a cloud provider. The fifth one is repurchase. Repurchasing, also called as replacing, is the strategy when the legacy application is fully replaced by a SaaS-based solution. The last and the most important one, which is what we are going to emphasize on, is re-architecting and refactoring. So just a call out here, this is pretty much what the application modernization is. So for highly critical applications that require cloud-native architecture, or applications that need thorough modernization due to outdatedness or performance issues, re-architecting, also called as refactoring or rebuild, is the strategy that usually leads to the highest transformation cost. However, it allows optimized use of the cloud, leading to the cloud-native benefits and making the application future-proof. So re-architecting an application often comes along with the opportunity to even break down the supported business processes into fragments, which greatly improves simplicity and makes a business process more agile. So as I was saying, application modernization is the process of updating and refactoring existing applications to take the advantage of new technologies and cloud computing platforms. This can involve a variety of changes, such as migrating applications to the cloud-native services, refactoring them to a microservices architecture, or just adding a new feature such as mobile support or artificial intelligence to the application business logic. Now, we talked a lot about what a digital modernization is, or how it encompasses the three facets of modernization around infrastructure, application, and database, but how it will look like in a real world scenario. So let's look at a real world example, how a fully modernized application architecture could look like. So this is just, again, a bunch of services that are put together. It doesn't necessarily mean that they are all going to be used at the same time. However, this gives you a fair bit of idea how a modern architecture for an application modernization, digital modernization, along with the infrastructure modernization, which was pretty much the first step towards the modernization, would look like. So on a Google Cloud platform, along with HashiCorp product suite, tools like Terraform and Vault, it offers a wide range of services and tools that can help businesses to modernize their applications. So on the extreme left, there are at the top left of the screen, there are external facing applications that are configured with services like Cloud Load Balancing and Cloud Armor. So load balancing provides that front end to the users without actually having to know the details of the backend services or backend resources that are actually addressing or that the application is running on. Cloud Armor provides that security control as the front guard, making sure the applications are safeguarded by the from the threats like DDoS attack and things like that. Then we also have some API-based platforms, so Apigee API platform or cloud endpoints for interfacing with applications via custom-developed API endpoints. Then we have native tools like Cloud Build in conjunction with third-party tools such as Terraform and Packer used to define infrastructure as a code. Application secrets can be stored securely in Secrets Manager or HashiCorp Vault. So they don't really need to be stored anywhere in the application code or stored in a static storage. So the secrets are stored in either Secrets Manager or HashiCorp Vault, and whenever needed, the API call is made to those services, and it fetches the credentials from there. The data encryption at rest provided to multiple services via key management system. The container images deployed using artifact registry and securing those images using signature validation and using services like binary authorization, which gives you that flexibility of making sure that the image that you are creating and you are authorizing to be deployed in a particular environment only that particular image gets deployed. When you have number of environments and the environment is so big, you will probably have different sources where the image is coming from, but you want to make sure that only the authorized images or the sources of images are only the images from an authorized source is being deployed into your containers. So that's where you will probably use something like binary authorization in this whole picture. Now, host data on cloud native services such as cloud storage, Cloud SQL, Firestore, or memory store. Again, depending on the use case, there are cloud native services that are provided, and you can make use of those services, whether it's a user-based data that you need to store, just maintaining the user data profile, or it's a transactional data, or it's just object data that you want to store. You can choose the appropriate service from the list of storage options that are available. Then just before the far right box, we have application, or we have services like PubSub or even Event Arc that gives you that flexibility of configuring the event-driven interaction. So you can have the event-driven interaction with the different services using PubSub or Event Arc. So as soon as an event occurs, the API hits the service that's available, and it runs the logic that you want to run once a particular kind of event happens. Then on the far right, we have Cloud Operations Suite. It is utilized for application observability. Actually, I shouldn't really call it Operations Suite, because we also have things like BigQuery and Data Studio. So more than observability, they also give you the dashboard capability for analytics purposes. So you see how from the very far left, we started with the front end of the application. Then we started going to the far right and making use of the services that are available on the cloud platform in the right way. I think that although we had been talking about the security posture that the public cloud provides and how secure and cost effective it could be, but what is more important is if you choose the right service for a particular job, and if this particular service has been configured in the appropriate way. Now, just before we wrap up our discussion around digital modernization and how it ties back to the infrastructure modernization, application modernization, and data modernization, I just wanted to touch upon some of the triggering factors. What are the factors, or what are the root causes, or what are the motivations behind thinking about a digital modernization versus cloud migration? So distinguishing application modernization from cloud migration, while closely related, application modernization and cloud migration have distinct focuses and scope. So the first one is around compelling moment or trigger. So what really triggers it? In most of the cases, the data migration starts being talked upon or start being discussed when the data center lease is coming to an end, as opposed to the application migration or application modernization, which is basically the discussion which starts happening when you are looking at improving the performance and the efficiency of your application. When we talk about the focus, so the application modernization enhances application architecture, whereas cloud migration, it primarily involves just shifting to the cloud. From a scope perspective, application modernization encompasses infrastructure, data, application architecture overall, whereas cloud migration centers on the application and infrastructure transition only. So it moves the application that's running on a set of servers or a box of steel somewhere in the data center on premises onto the cloud. Some of the benefits from application modernization, it fully leverages cloud technology's potential. As I was showing you how we can use the powerful synergy between the cloud platform services, cloud native services, and some of the tools from HashiCorp like Packer and Terraform to utilize infrastructure as a code and have the continuous CI/CD pipeline built, which does the continuous integration, continuous development, and deployment. Whereas cloud migration primarily taps into the scalability and flexibility of the public cloud. So the last but not the least differentiation is around required skill set. So there is a new set of skills, there's a new set of mentality that is required when you are going through a modernization journey. A new set of or new way of handling the infrastructure, handling your operations is needed. Whereas when you are doing the migration, it is basically moving the application or your resources from on-premises to the cloud. Although it needs a bit of upskilling in terms of learning the platform, but it is completely different from the skill set that's needed when you're talking about the digital modernization. Now, in the quest to harness the power of cloud technology, application modernization, I believe, is a pivotal strategy. By understanding infrastructure modernization, data modernization, and application modernization as interconnected components, business can embark on a comprehensive journey to transform their applications and fully embrace the potential of cloud technology. Application, infrastructure, and data modernization are all essential components of a comprehensive digital transformation strategy. By modernizing all three areas, organization can improve their agility, scalability, and efficiency, and then gain a competitive edge in this digital economy. Remember, it's not just about moving to the cloud. It is about optimizing applications for success in the modern digital landscape. Thank you very much. Thanks for your attention. I'm open for your questions and discussions. And yes, here are my details. If anyone wants to connect with me, feel free to send through a request on my LinkedIn profile, or I've got my website listed there, dineq.com. So feel free to reach out to me. Thank you.
Cool. Thanks, Anupam. That was a great talk. Application modernization is one of my favorite topic when we have this cloud computing coming into picture. Yeah, leveraging them and moving from monolithic to microservices based architectures, and also it's covered a lot. So yeah, good, like very nice topic to listen to. And yeah, thanks, Anupam. Just wanted to remind again, if you would like to learn about HashiCorp tools and products, you want to get more involved with the community, we invite you to join HashiCorp user groups close to you. I think there are more like 18 plus have groups all over the India, and we encourage you to join one of that which close to you, or you can start your one if you don't have in your city where you live. Yeah, you can more than welcome to start. Reach out, Jasmine. She could help you how you could do that. So yeah, so I will also drop a link to explore more about community in the chat as well, so that you have that. So yeah, there you go. And with that, I would like to invite our next speaker, Anup Chaudhary. He has 6 years experience in IT, working with IT arm team in ServiceNow. He's based in Uttar Pradesh, like outdoor sports. So let's hear about from Anup on empowering cloud acceleration with ServiceNow and Terraform. Over to you, Anup.
Hi everyone, I am Anu. Welcome to my HashiTalk. A brief intro about me. I am a senior developer in ServiceNow. I work with IT operations management team. I have around 6.5 years of experience working in IT with different domains. This is the brief overview of this talk today. I will talk about challenges in cloud management and governance that our team is solving. I will cover what is a catalog and what is a cloud service catalog, why we need it, and how we can create it using ServiceNow platform and Terraform template. Then I will talk about pre-built cloud service catalog items that we are offering as a content, and I will showcase a small demo how we can use cloud service catalog backed with Terraform template to order a Linux VM from cloud. Terraform is a IAC tool. We can use Terraform's declarative code to define and provision infrastructure in cloud. It provides us flexibility to use different cloud provider. Let's say you have credentials, you have Terraform template, you can connect to cloud, you can provision resources, but where is tags, where is connection to the application, where is information about who approved it, which team does that person belongs to? So these are the open questions that we solve. You deploy something in cloud, how to bring it in database is application team's problem, but we automatically do it as a part of request fulfillment process, and we run discovery schedules to bring it in CMDB database of ServiceNow platform. When it comes to scaling cloud adoption in the enterprise and make it easy for developers and other users to adopt cloud, the number one question is how we can provide self-service catalogs. Typically, developers have automated tools to create cloud environments, provision resources, but often they might not adhere to corporate policies. We provide automation of cloud request, incident, and change management process. We can scale cloud services with service operation process automations. It drives process adherence needed for large enterprise with frictionless experience driven by modern automation techniques. Once these services are up and running, we help provide a complete visibility via tag and event-based discovery. ServiceNow catalog is like an organized menu of services and products. It's a one-stop shop where employees can easily request and access various resources, services, and items they need. An individual item on that organized menu is called catalog item. It represents a specific service, product, or action that the user can request. For instance, it could be ordering a laptop, requesting software installation, or initiating a server deployment. Cloud Service Catalog, aka CSC, is the ultimate cloud services provisioning and management tooling, which allows customers to automate their cloud request processes. It is at the core of Cloud Accelerate. It streamlines the cloud provisioning request experience while bringing complete control of cloud resources, provisioning, and management. A cloud catalog item have set of variables that captures the details during service requesting. It has associated workflow which defines the step and processes involved in fulfilling a user's request. Once we submit a cloud service request, it goes through multiple stages. It may include request submission, approval, policy and quota checks, deployment and completion. Cloud Service Catalog item has an order form, a simple UI to capture request details. The details are used during provisioning of resources and performing any actions in cloud. We can convert a Terraform template into a Cloud Service Catalog item. We need connection details to access Terraform template from VM or supported VCS in ServiceNow instance. We just need to discover Terraform template in ServiceNow instance and ingest the template into a catalog item on Cloud Admin Portal. Once you create a catalog item, workflow and provisioning steps gets added. You can add your own custom pre and post provisioning steps into catalog item. We are supporting Terraform open source, enterprise and cloud. You can use AWS, Azure and vSphere cloud providers in Terraform templates backed catalog items. GCP support is in pipeline. End user can access all cloud catalog items from Imply Center on ServiceNow instance. Other than Terraform templates, we are also supporting ARM and CFT templates. On previous slide, I talked about how we can convert a Terraform template into a cloud catalog item. Here I will talk about out-of-box content, which includes policies, actions, guided setup, and pre-built catalog items for IaaS and PaaS offerings backed by Terraform templates. We are offering cloud catalog item for major cloud provider. For AWS, cloud catalog item offerings are Windows and Linux EC2 VM S3 bucket, Windows and Linux EC2 VM with security groups, Windows and Linux VM with multiple disks. PaaS offering for AWS is DynamoDB, and for Azure catalog offerings are Linux and Windows VM, Linux and Windows VM with multiple disks. We are offering a catalog item to provision Azure DevOps pipeline also. Pre-built catalog items require day zero configuration. There are multiple steps that are required to be completed before we can use the out-of-box catalog items. These steps can be setting up cloud account, setting up Terraform box with necessary templates. Guided setup streamlines those steps and help us to complete those steps quickly. We are offering predefined cloud policies that can be applied before or after provisioning cloud resources. As an example, a provisioning request for a VM with large size automatically triggers an out-of-box approval workflow. Some actions are applied to provision and discovered cloud resources to manage them most efficiently. One example is the built-in lease policy, which automatically decommissions the provision stack when lease expires. Let's see a demo of cloud resource requesting. Using pre-built cloud service catalog item, we will use ServiceNow CSC and Terraform connector to provision the resource in AWS cloud. Let's see how to order an AWS EC2 Linux virtual machine with the ServiceNow Agent Client Collector from the ITOM Cloud Services catalog. This will help you get your VM up and running fast. To order our VM, we will go to the Cloud Services catalog and choose AWS Linux VM. That takes us to the order form. Here we will specify the details for the VM itself and for provisioning. We will also include agent client collector. When we are done, we will place our order and check out. Our request is not for a pre-approved VM size, so it goes to an administrator for approval. They will verify the details and approve the request. In our request summary, we can see the steps as our request is fulfilled. In the request details, we can watch as the stack is deployed. The stack view shows more details, including a notification that follow-up is required. That means a problem in the provisioning process has created task for a cloud operator. The operator's catalog task list shows two new tasks. When the operator completes the task, our activity list shows them close complete. The next time the VMs are refreshed, the stack will become active and our new VM will be ready to use. For more information, see our product documentation or knowledge base or ask a question in the ServiceNow community. Thank you for listening. Have a nice day.
Cool. That's a very nice talk. Anup, thanks for the talk. Yeah, it's been more getting popular on the service catalogs for your organization internal customers to make their life easy. So yeah, this is something I think more organizations are working towards and exploring as options to integrate with the cloud providers. And yeah, nice talk. Thanks, Anup. Just to remember, all the talks we are sharing today, it will be shared in YouTube in the coming weeks. And if you're just tuning in, you can catch up later. So no worries. So I would like to introduce our next speaker. If there are no questions, I think I'm just checking the chat. Okay, all good. So our next and final speaker would be Kirtivasan Kannan. He's talking about GitHub Terraform module registry. Yeah, I think he's also an AWS community builder. I've worked with him before. Kirtivasan, stage is all yours.
Welcome to Talks India series. In this session, we'll talk about how to use Git as your Terraform module registry and also how to handle the versioning and the best practices around that. To give a brief introduction about myself, Vasan, having close to 8 years of experience in IT, and I play a senior cloud engineer in a private company called Mahindra. You can connect me in LinkedIn under @Kirtivasan-Kannan. Myself also hold 5 AWS certificates plus Terraform Associate certified. As a hobby, I run 2 YouTube channels, one eViday and the another one TechPage. Both I make content around AWS, DevOps and Terraform. The eViday I make content in English, whereas the TechPage I make content in the regional language Tamil. The today's agenda is going to be, we start with what is Terraform, why Terraform, and why not any other providers other than Terraform. Also, we talk about how to create a sample resource using Terraform and the purpose of the module itself, why not limited to resources, why we need module, and how to place a module in a centralized location, something like Git repository, and how to handle the versioning for the modules placed, and what are the best practices to tackle when placing the modules in the central location like Git. So that's the entire agenda it's going to be. So I would be around in the YouTube chat session all over the during the session. So for any queries, feel free to ask in the chat, or you can also reach out over LinkedIn if you're watching the recorded version of the session. As many of you know, the Terraform, it's mainly used for as an infra as code approach, so that we don't go and manually create the resource, and we do it as a code format, so that we can track what actually is getting changed and the history of the infra itself. Also, it's easy for the state file management. We can see like what resource has been created and how it is being currently managed. It also helps you to track your change, like who changed, what been changed, and so on. The same thing can be also offered in other competitor services, but why Terraform, or what cutting edge Terraform providers? It provides multi-cloud. So if you are in AWS, you might be limited with a specific infra as code provider that is limited to AWS, whereas Terraform, it also supports Azure, it also supports AWS, GCP, and so on. It's not just limiting to multi-cloud, but other than cloud services, the Terraform providers are also available in multiple areas. For example, if you're targeting about DNS, then there is a provider for Cloudflare, and this is a sample list which you can self-explore by visiting the page Terraform browse/providers, where you can see all the list of providers which is currently associated with Terraform, to see like what you can make infra as code in your day-to-day life. So it's easy to say, like you can avoid manual change, you can avoid track the resources. So to see it in action, like how much difference it can make with and without the code. So for this scenario, I took an example of creating an S3 bucket manually, and also destroying the S3 bucket manually. Let's see like how many click and how many ways you want to navigate it. So if you see, like first I make a click, one click for creating a bucket, and then the second click for typing out the bucket name, and here the chances of making typo is there, and then you scrolling down, and then making the third click for creating the bucket. So just for creating a bucket, I'm making 3 clicks. Now the same for deleting the bucket, I already made one, and now I want to make the second click and type all the way of the naming conventions of what bucket I need to create, and then the third click for deleting it. So it took 3 clicks for creating a bucket, typing out the name, and another 3 clicks for deleting. Again, I need to type the bucket name which I want to delete, and in both the process there can be a manual typo can occur, and there is no peer review exist in the entire process. So let's see how it would look in the world of with Terraform. So we will be replacing all those actions with just 4 lines of code with a resource block. That's how it's going to ideally look, and we are going to input this the bucket name alone as part of it. And when we execute it, it's going to be just the 3 commands. So first you are going to initialize the code locally, and then you would do the, once the provider has been initialized locally, then you are going to perform the apply action, and it would ask you for the confirmation that these are the resources are going to get created, changed, or destroyed. And if you're happy with it, you can provide yes. Even you can provide the yes step by using -- auto approve flag by passing it, so that it won't even ask you for approval. It's more like a pre-approved state, and done, your resource will be created. And now, from now, once you have the working code, you can destroy the resource with just a single command of terraform destroy. And if you want to recreate it, you can recreate it. If you want to destroy again, you can destroy and play with it a number of times. So I took S3 as an example over here, whereas the same case would apply for EC2 or S3 or Lambda. And think about a complex scenario where you want to uh, build your infrastructure which would need multiple components like load balancer, backend server, the front end certificate, and so on. So with this infrastructure approach, you can avoid all those hassle of clicks and huge chance of error, and everything can be converted into a bulletproof mechanism of infrastructure code. So there's a major difference between with and without the Terraform. So now if you see the code itself, it's not just the resource creation, right? I might be having some additional scenarios like updating of tags, which is again I can easily pause it, or I might be having some standard set for my company. For example, let's say whatever the S3 bucket I create, it should have a prefix TP hyphen in front of it to identify it's a company bucket. Or you want to mandate the tag for your cloud uh, pricing pricing visibility, so that you might need to mandate what tags to be created as part of the resource creation, right? But then if you see in real world, the most person who need of the AWS resource may be your developers, and you don't want your developers to worry about, am I passing the right tag or am I passing the right naming convention which my company wants to, because they might be having a lot going on. So also even if you're passing the responsibility to the developers or the person who are creating the resource in your org, then again you would end up in terms of repeating yourself, as if for each S3 bucket you create, you end up passing the tags, or you end up typing a TP hyphen as part of the resource creation. The best practice when it comes to coding, it's something called don't repeat yourself, the dry concept. And that's where exactly the module kicks in. So the module helps you to variabilize the repeated standard of your code. So in this case, it would be the TP, which is a prefix, should be like standardized, and also the tag which you want to hard code it. So that's how the module can be formed. And you might be noticed like it's still a resource block, right? So what's the difference between a module and resource? So in module, you create a resource with variabilized format, and then you would be referring that specific the resource block within your module block and get the resource created. So if you see on the right side in the module section, that's how the folder structure would look like. Within the S3, the resource block would lies, and then within the demo folder, your actual module block would lie. So the quick demo for like how it would look like when we are trying to create a resource. So we're going to keep the module block within the S3, and then in the demo block, we're going to actually create a resource, and both the folder would contain the definition of providers, because it would need to know what are the prerequisite providers it would need to use. And all you would need to do is you would say the initialize the one Terraform init, and then you would do the Terraform apply post creation. So let's say for a developer, they might be having a requirement for creation of another bucket, right? So all they can do is they can just use the same module template, and then just pass the new bucket name that they would need in, so that you are not repeating yourself, or you are not worried about is a new resources created with the right tagging, or is the naming convention is followed by the developer. So in case if you want to avoid like duplications of like for example in this case we are saying like prefix it with TP and TP, right? So if you want to avoid the duplication of like TP and TP, then you can play with validation and other things in the variable. I'm not going deep into that, but this is how you can simplify the process of the creation of the resource and templating it with the module. So far what you have done is we are creating the module and keeping it all over the place of locally. So everything is happening within the folder structure, and even we are referring the folder with dot dot slash s3, which is like locally exists, right? So how we can use Git as a module registry? So all you would do is whatever the files which exist under the S3 folder, because that's what we are using as a module when we are doing it locally, we'll be placing it in a Git repository. So in this case, I create a repository called Hashi module demo, and I'm just following the same folder structure like S3 and move all those files from a local system into the Git repository. The push commands for Git repository might be out of session, but you can also go to the UI of the Git if you're not familiar about Git, and it's basically a versioning control system where you can track what changes been done, who made it, when, all under the commit history. So now, so far we are referring it locally, right? The source block, it says the folder of the S3. So since we are moving it into a Git repository, all you would need to do is just change the source block value into the Git repository. So you would need to pass the value of SSH equivalent of the URL for your Git repository, and that's it, it will start working. But here, if you see, we are directly mapping it to the Git repository, but our folder structure, which in our example, the actual module is not lying in the home directory, but it is lying within a folder called S3. So how we can say or Terraform saying that, hey, this is a module, you don't directly refer to the home directory of the repository, but I want you to precisely go and look into a folder called S3. So how can we say that? It's very pretty straightforward. All you need to do is from the value of your repository SSH value, you need to suffix it with / your folder name. Since in our case, I named the folder name as S3, I'm adding the suffix of S3. If you are creating a module for ALB in the folder name ALB, then you can say like / ALB. So it's just the folder name. If you're having like folder subfolder, then you can say like / S3 / let's say bucket, something like that. But in our case, it's straightforward. So which lies within the first folder called S3. So I'm naming it as the S3 itself. Okay, so now comes a part of versioning. Why versioning? It's not just part of the code, but our module also will evolve as our organization evolves, right? Because currently I might be having a requirement like my S3 bucket should prefix with the value TP, and it should contain the tags name and environment in it. What if tomorrow my organization will change? I want to rename from TP into uh, EVDI, or what if I want to add additional tags as part of my resource for some building purpose, maybe like team equal to. So it can change, for which the versioning of the module is mandatory. So how can we handle the versioning when we are moving into Git? Is by using the tagging options already available as a Git itself. So you would just need to know the two commands to tag your changes. The first command to tag your change would be git tag -a, and then the version. So in our case, I'm just making this 1.0, and you can give the nodes for your version, like what changes you are doing over there. This can also act as a change log, and then you can do push your changes or push your tags to the remote repository using a git push ---- tags. And now if you go to the Git repository, you would see the tag section over there, and if you click there, you can see the version number of your tag, and then the nodes which you added when you push the changes over there. So now we have created a tag, but how can I tell my Terraform you need to refer this specific tag or this specific version, right? So currently, if you recall, we are just saying go to this repository and this folder, but now we want to say Terraform go to the specific tag of the repository. So to do that, you would use a ref query parameter like $ref equal to your tag name, so that the Terraform knows it's not just to fetch any the main branch, but it would need to precisely specify the requirement tag to fetch it down under a specific folder called S3 and then execute the command from there. So this is how you can handle the versioning in the Git. So the major common versioning strategy they use something called semantic versioning. It goes something like this. You can see like 1.0.0 and any new changes you put it into the module, you can bump the numbers based on the impact it creates to your module. So the standard they follow is the first one or the first value here they stand it's for major one, which means it's going to break your existing change. So let's say I'm renaming my TP into E with I or XY, then the existing S3 bucket would get destroyed because I can't just rename the one, right? So which means it's going to break my existing infrastructure. It's going to create an impact. So in that case, it's a major one. So if I'm going to rename my resource or it's my resource is going to destroy, in those scenarios, I would bump the version 1 to 2. The minor is something, you're adding something new to the existing setup, but it's not going to create a major difference. Let's say I'm going to add a new tag value like team name equal to uh, the value of the team name. So in this case, it's just appending a tag to the existing resource. It's not going to create a huge impact for the existing resource. So in that case, I can just bump the minor version of it. The bug, it can be like, let's say you started with environment as e caps, but you realize you want to have everything lowercase, so you are updating the module from the environment tag name from e uppercase into the e lowercase. Then it's more like a bug or a minor fix. Then that you would add the final 0 incremented one. So hope you got the difference, like a major, minor, and bug. So major is more like there is no rollback. Minor is like if you want to roll back, you can do that, and it's not going to destroy any of your resource. And bug is more like for the existing change, there can be a typo or some adding nodes or likewise. So taking this approach of semantic version can create chavos like what exactly got changed, right? It can be a tricky part. So that's where you would need to maintain something called change log as a best practice, so that you know what changed and what exactly the difference between 1.0 and let's say if you're introducing new version 2.0, what change it got introduced as part of 2. So when you go as a Git repository module, you same like how you should do for like readme.md, you can also do the same thing for changelog.md, so that you have a proper version like what changes and what are the new changes from the difference between version A and version B, and people can choose either they want to update their version or not required. So now let's talk about few best practices which you need to keep in mind when it comes to taking this approach of moving the repository into the Git one itself. Yeah, so moving the module into the Git one. The main one for the first thing is keeping the end user, build the module, keeping the end user in mind. So what we meant by this is we don't want to complicate end users, or like we don't want to collect details like for example tags, right? So all those tags can be done behind the scenes, and you get the bare minimum requirement from the end user, so that they provide very minimal input, and the infra is created backend with all the standards you need. And don't try to make it region bounded, like don't add providers of US specific within the module, and give that part into the resource creation people, so that when they are referring your module, they can choose where your resources to be created. Else that's create chavos in future. If they want to expand the resource creation to different region, then you want to bring in additional changes to your module which is unneeded. Variabilize as much you can, so which means don't hard code it, hard code the things which you want to standardize, whereas even if there are something like you wanted to standardize, let's say like TP, and you want to change it, you can variabilize that and then keep the default value as TP, so that when they are creating a bucket, if they pass it, they can create with a custom prefix. You know, you never know when the requirement change, and if we can variabilize as much we could, even there is a minor exceptional case which you want to divert it, we don't need to do any changes in the module, and still it can be done with the variable itself. Also document the details with sample. Let's say if you're creating a module in a Git repository, it's wise to create a folder for sample folder, so that if any of the user is referring your module, they can see how the module block to be called and what are the mandatory variables to be passed to get the resource created using your module, and are they, so that if they're complete new beginner to the Terraform, they don't need to go here and there to get the resource created. They can just use your snippet and documentation part, get the resource done. If you're planning to create resources or create module for multiple services, let's say S3, EC2, Lambda, and so on, or maybe like cloud provider, or sorry, maybe the cloud front, or many. In those cases, try to create individual repository so that you have each repository act as a module, and if any update required for the module can be handled without impacting any other. Else the versioning and other things can make a bit tricky if it's all went into a single repository. You can also create a module combining other modules. For example, for a website, you can have S3 as a separate module, and load balancer or EC2 as a separate modules, and then make a combined module together as a separate repository. So there are like multiple ways to handle it, but always try to go as an individual repository per module based cases. Yeah, so these are the generic best practice how you can handle if you are like a low level company, or like you are using Terraform but not to a certain huge impact, and you don't want to spend so much money on third party providers like Spacelift or for your model management. Those things can be handled in a simplistic way using the Git as a module registry. So that's more around this session, and that's what I wanted to share it today. So if you have any questions, feel free to ask. I will be around in the comment section of the video, and you can also reach out to me over the LinkedIn. Yeah, so thanks all for your time. I will be waiting for your queries to get it answered, and this is my LinkedIn handle where you can ping me or we can connect and discuss further of any of your future questions, or if you're trying it on your own, you're facing any hands-on difficulty, feel free to reach out to me. So thanks for the opportunity and thanks for your time. Cheers.
Cool. Thanks, Hege. That was very detailed talk. So yeah, I appreciate that. That's really good. Yeah. So just to say, Keke is also an AWS community builder. Thanks for all you do, Keke. Personally, I think you're very active in the community member as well. So you add a lot of value for HashiCorp, AWS, and other communities you support. Thank you. Just three bits in my list before we wrap up. I think so. All these talks we see today are coming up in the YouTube in the coming weeks. So you please, yeah, if you miss something, you talk, yeah, you can always go back and watch the talk. And we also have a sixth annual 24-hour virtual event coming up, HashiTalks 2024. This event will begin at 15th of February, noon GMT, and you can register here. I will send you the link. Here we go. And we also have, community. It's all about community, right? So I don't know if you're already active in HashiCorp community, if you're already using HashiCorp tools, you want to be part of it, you want to grow the community in your place, wherever you're from India, feel free to, search for the local user group near you. If not, feel free to start. Yeah, contact me anytime, contact Jasmine. We are, happy to help. Yeah, this is what I have in my script. Jasmine, you want to add anything before we closing, or?
I just want to say thank you. It was, like I said, it was great meeting you at reInvent. I am so happy for all that you do in the HashiCorp community as a hug co-organizer. I'm really excited. Like you can speak best about the HashiCorp user groups because I work for HashiCorp and I'm impressed by you all. But you actually run a user group, so that's really awesome. And I'm excited to say that as a result of this event, we have someone that has already reached out to start a hug in
Wow.
South
Good.
India. So that's really awesome. I'm going to get back to that person. I might need to catch up on some sleep first, but I'm definitely going to get back to that person because we want to see the community grow. So, with that,
That's
I just
cool.
want to say thank you to you for joining, for agreeing to be our co-MC for closing out this event. And I want to thank all of our speakers for
You were
being here. And I want to thank everyone else who all of our viewers, all of the community, all of the practitioners who learned something today. And I really hope to see you all in the future. So thank you so much.
Thanks, Jasmine. Thanks again. Driving the nuts and bolts behind the scenes and yeah, helping the community, bringing all the communities together globally. Yeah,
Yeah,
not just in one location. So, Alexandra, your
yeah.
community, yeah, Chris, you guys are doing a very great job. So, thank you.
Thank
I want
you.
to sign off before we do. I just want to say, yeah,
That's
all my
awesome.
fellow Indians, yeah, Jai Hind, and yeah. Have a good day. Bye,
Thank
guys.
you so much. Bye.